Hello everyone, in this video we're going to explore topic 9.1 defining and differentiating parametric equations. Now first we're going to graph parametric equations. Definition of a plane curve: if f and g are continuous functions of t on the interval I, then the equation s equals f of t and y equals g of t called parametric equations, and t is called the parameter. The set of the points s and y obtained as t varies over the interval I is called the graph of the parametric equations. Taken together, the parametric equations and the graph called the plane curve denoted by C. When sketching a curve by hand represented by parametric equations, you use increasing values of t. Thus, the curve will be traced over a specific direction. This is called the orientation of the curve. You use the arrows to show the orientation. Alright, so let's take a look at the first example. Sketch the curve described by the parametric equation s equals t squared minus 4 and y equals t over 2 for t from -2 to 3. Alright, now if t equals -2, you substitute -2 for t into the equation right here, right? So s equals 0 and substitute t into this equation right here. So y equals -1, right? Similarly, t equals -1, t equals 3, it's going to be 5 right here, and it's going to be 5 over 2, right? Alright, now let's plot these points on the xy coordinate right here. So x equals 0, y equals -1, it's going to be right here, right? This one is the starting point. X equals -3, y equals -1/2, so it could be right here. X equals -4, y equals 0, it could be right here. X equals -3, y equals 1/2, right here. X equals 0, y equals 1, it could be right here. And x equals 5, y equals 2.5, so it could be right here, right? So you just connect this point. Alright, now you just put the arrow starting from here. Now we can use the calculator to check our work, right? So you're gonna bring up the calculator at graphs right here. You need to go to menu, graph entries. You need to change this one to parametric, which is number 4 right here. Alright, the first equation is x right here, t squared minus 4, right? So you just input t squared minus 4 and y equals t over 2, right? And for the domain of the t value, it should be -2 to 3. So you just override this one, -2 and 3, right? And the t step right here, you just leave it. And you hit enter, it's going to be right here. Now, if you want to see how the graphs moving, just press menu, trace, and then plus right here. And press number 2 right here, right? And you just press the stop animation right here. And just enjoy how it looks like. And then it's gonna stop right here, right? It stop from here and stop right here, right? Now let's move on to example number 2. We do exactly the same thing as example number 1, right? Now t equals 1, substitute over here, you have sine pi over 2, it's gonna be 1, it's 1, 1. T equals 2, substitute over here, it's gonna be sine pi, it's gonna be 0. This guy 2, right? T equals 3, sine of 3 pi over 2 is going to be -1. This guy 3. T equals 4, substitute over here, it's going to be sine of 2 pi is going to be 0. And this guy is 4. T equals 5, sine of 5 pi over 2. it's gonna be 1. And this guy should be 5. And t equals 6. Substitute over here, it could be 3 pi. It's gonna be 0 and this guy 6. Alright, now you're gonna plot this point on the x and y coordinate, right? X equals 1, y equals 1. It's gonna be right here. X equals 0, y equals 2. It's gonna be right here. X equals negative 1, y equals 3. Right here. X equals 0, y equals 4. It's gonna be right here. X equals 1, y equals 5. It's gonna be right here. X equals 0, y equals 6. It's gonna be right here. Alright, so if you connect this point, it's gonna be something like this. Now you just place the arrow right here. Alright. Now observe that if you let x equal, t equals 0, and then x should be 0, right? So we have the left endpoints right here, 0. Y should be 0, so it could be the origin right here. Right? So you just connect this guy. And you see that it's gonna go this way, right? Now you're gonna use the calculator to check your work, right? So you're gonna hit tab x2, y2, right? You need to hit upper arrow right here. Alright, so you're gonna put sine of pi t over 2. So you're gonna press check right here, sine of pi t over 2, right? So pi should be right here, and t divided by 2. Now y should be t only. Now the value of t is from 0 to 6, so you need to override this one. 0 and 6. You hit enter. It's gonna be right here, exactly, right? Now if you want to see how the graph moving, you just press menu, go to trace, number 4 and number 2. Press enter. Now let's move on to the next one, eliminating parameters. Example number 3. Sketch the curve described by the parametric equations. X equals this one and y equals this one, where t is greater than negative 1, by eliminating the parameter and adjusting the domain of the resulting rectangle's equation. Alright, so we have s equals 1 over square root of t plus 1, right? From this equation, we need to solve for t, right? Now, square root of t plus 1 is 1 over s, right? Square both sides is going to be t plus 1 equals 1 over s squared, right? Then subtract 1 both sides, so t equals 1 over s squared minus 1, right? Now substitute this one for t into the function right here, right? So we have y equals 1 over s squared minus 1 over 1 over s squared minus 1 plus 1, right? So this guy turns out to be 1 right here can be written as s squared over s squared, right? So I have 1 minus s squared, right? Over negative 1 right here and 1 right here cancel out. I have 1 over s squared left, right? It's 1 over s squared right here. Now since I have s squared left right here, I need to bring it to the bottom, so it can be s squared right here, right? So this guy right here and this guy right here cancel out, right? So the answer is 1 minus s squared. This one is the y value, right? So y equals 1 minus s squared. Now we need to adjust the domain of the resulting rectangle equation, which means we have t greater than negative 1. Does that mean this guy always greater than 0, right? Then s right here must be greater than 0, right? So this one is the quadratic functions, right? So x equals 0, y equals 1. We have the first point right here. X equals 1, y equals 0. Right? It could be right here. X equals 2, y equals negative 3. So it could be right here. Right? So if you connect this one, it could be something like this. Now, observe that s always greater than 0. Actually, you have another branch on the left hand side right here, but we don't need that one, right? We only need the one on the right hand side because s always positive. Alright, so you just place the arrow. Now you may use the calculator to check your work. Now let's move on to definition of smooth curves. Let's see denote a plane curve represented by parametric equations s equals f of t and y equals g of t for t between a and b inclusive. Suppose each function s of t and y of t is continuous on the closed interval a and b and differentiable on the open interval a and b. If both ds over dt and dy over dt are both continuous and never simultaneously 0 on the open interval a and b, then C is called a smooth curve on the closed interval a and b. Alright, let's take a look at this one. Differentiating parametric equations. Theorem 1. Parametric form of the derivative. If a smooth curve C is given by the equations s equals f of t and y equals g of t, then the slope of the curve C at the point s and y is dy over ds. Now I'm going to divide the top and bottom by dt, so I get this one right here. Right? Observe that ds over dt right here must be different from 0, so that this guy defined. Right? Now, horizontal and vertical tangent lines. Remember, we have the Christmas tree trick. If the lines go in this way, the slope is positive. If the lines go in this way, slope is negative. If the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Right? Now, we're going to talk about the horizontal tangent line. At a number t where dy over dt equals 0, but ds over dt is not equal to 0, right? Look at this one right here. If this guy equals 0 and this guy not equal to 0, then dy over ds must be equal to 0. But dy over ds is the slope, right? So then a smooth curve C has a horizontal tangent line, right? Because dy over ds becomes 0, it could be right here. It could be horizontal line, right? Now add a number t where ds over dt equals 0, right? Which is the bottom right here equals 0, right? So does that mean the whole thing right here must be undefined, right? Then dy over ds is undefined. In other words, the slope is undefined, which is the vertical right here, right? So we have the vertical tangent line, right? Now let's take a look at example number 4. Consider the plane curve defined by the parametric equation s of t equals 3t squared and y of t equals 2t. Find an equation of the tangent line to the curve when t equals 1. So you need to use the point slope form formula, right? Y minus y1 equals m times s minus s1, right? Now you need to find the slope first, right? The slope actually dy over ds, right? So it's going to be dy over dt divided by ds over dt, right? Dy over dt, which means you need to take derivative of the function y right here with respect to t. What does that mean? It's going to be 2, right? And ds over dt, you're going to take derivative of this one with respect to t, right? So it could be 6t, right? Then you substitute 1 for t right here, right? So then dy over ds when t equals 1 becomes 2 over 6 and it's going to be 1/3, right? You need to find the value of y1 and x1, which is the coordinate point, right? So you just substitute 1 for t into the function right here to solve for x and y, right? So t equals 1, you have s equals 3, y equals 2, right? Then the equation is y minus y1, which means 2 equals 1/3 times s minus 3. This one is the equation of the tangent line, right? Now, question B. Find all the points on the curve at which the tangent line is vertical, right? So you know that the tangent line is vertical when ds over dt equals 0, right? So you have ds over dt equals 0. Then you have set t, right? Because you take the derivative of the function s of t with respect to t, right? So it could be 0, and then t equals 0, right? Now, you need to find the order pairs, right? So substitute 0 for t back to the equation right here, right? So you have s of 0 is 0 and y of 0 is 0, right? So the vertical tangent line to this curve is at 0, 0, right? Now let's move on to example number 5. A curve that crosses itself. A plane curve represented by the parametric equations s of t equal tq minus 4t and y of t equal t squared crosses itself at the point 0, 4 as shown in the graph to the right, and thus has two tangent lines. Find the equation for these two lines, right? So again, in order to find the equation of the tangent line, you need to find the slope, right? So the slope is going to be dy over ds equals dy over dt divided by ds over dt, right? Now, the top one, take derivative of the function y with respect to t, right? So it could be 2t. Now, the bottom, take the derivative of the function s with respect to t, right? So it could be 3t squared minus 4, right? Now, given the point 0, 4, which means s equals 0, y equals 4, right? So I substitute 0 for s into this equation right here to solve for t, right? So I have t cubed minus 4t equals 0, right? So this guy turns out to be t times t squared minus 4 equals 0, right? And then t times t minus 2 times t plus 2 equals 0, right? Then you have t equals 0 and t equals plus and minus 2, right? You substitute 4 for y into the second equation right here. So you have t squared equals 4. Then t equals plus and minus 2, right? So you have three values. Now you need to check each value. For t equals 0, then you have s of 0 equals, substitute over here, you have 0, right? And y of 0 is 0, right? And you look at this one right here, you have the order pair 0, 0. 0, 0 right here is not the intersection, right? T equals 2. Then you have s of 2 equals 8 minus 8. It's going to be 0, right? And y of 2 equals 4, right? So you have the order pair 0, 4. This is the intersection right here. So this is works, right? Now t equals -2. You have s of -2 equals -8 plus 8, right? Equals 0. And y of -2 is still 4, right? So the order pair right here is still 0, 4, right? So you're gonna cut this one out, right? You don't need this one, right? Because this one is not the intersection, right? You have two values, t equals 2 and t equals -2 right here. And since you have the intersection right here, right? So go back over here. You need to find the slope of the tangent line, right? So you have dy over ds evaluated at t equals 2. Substitute 2 for t into this equation right here, right? So you have 4 over 2 squared equal 4 times 3, it could be 12 minus 4, it could be 8, so it could be 1/2, right? And second one, dy over dt evaluated at t equals -2, right? So 2 times -2 equals -4. This one should be 8, and the answer is -1/2, right? So you have two tangent lines. The first one has the slope right here. The second one has the slope right here, right? And you see the order pair is right here and right here, right? So the first equation, y minus y1, which means -4, equals the slope, which means 1/2, right? Times s minus s1. S1 equals 0 right here, so you don't need to write it, so just write s, right? The second equation, y minus 4 equals -1/2 s. That's it, right? Now let's move on to example number 6. A projectile is fired at an angle theta from 0 to pi over 2 to the horizontal with an initial speed v0 meters per second. Assuming no air resistance, the position of the projectile after t seconds is given by the parametric equation. S of t equals v0 cosine theta times t. Y of t equals -1/2 g t squared plus v0 sine theta t for t greater than equal to 0, where g is the acceleration due to gravity. Find the slope of the tangent line to the motion of the projectile as a function of t. Alright, so we have dy over ds is the slope of the tangent line, right? So this guy turns out to be dy over dt divided by ds over dt, right? Now, the first one right here, you need to take the derivative of the function y with respect to t, right? So this guy turns out to be -gt, right? Plus v0 sine theta, right? Now, take the derivative of this function with respect to t. It's going to be v0 cosine theta, right? Now let's move on to question B. At what time is the projectile at its maximum height? Now go ahead, sketch the graph. It's going to be something like this, right? The maximum height, which means the highest point right here, right? So right at the highest point, you have the tangent line, right? It's going to be right here. And of course, the tangent line should be horizontal, right? When the tangent line is horizontal, the slope is 0 right here. Look, this one right here, right? So you have dy over ds equals 0, right? It's the same thing as this guy right here equals 0, right? And this one is the fraction. You only need the numerator equals 0, right? So you have -gt plus v0 sine theta equals 0, right? Then you just solve for t, right? So -gt equals -v0 sine theta, right? Divide both sides by -g, so t equals v0 sine theta over g, right? And this one is the final answer. We're going to explore topic 9.2, second derivatives of parametric equations. Alright, so we're going to use this theorem to find the higher order derivatives parametrically. d squared y over ds squared. This is actually the second derivative. So you're going to take the derivative of dy over ds with respect to s. Then I'm going to divide the top and bottom by dt, right? So it turns out to be derivative of dy over ds with respect to t over derivative of s with respect to t, right? Now similarly, you're going to take the third derivative. It's the same thing as you're going to take the first derivative of the second derivative right here, right? Now let's take a look at the first example. Finding the second derivative of a parametric equations. Find and simplify d squared y over ds squared for each of the following, right? So given the function s of t equals e to the t and y of t equals t times e raised to the negative t, right? First, you need to take derivative dy over ds, right? It's the same thing as dy over dt divided by ds over dt, right? And then you're going to take the derivative of this one with respect to t, right? So you're going to use product rule, right? Use times v derivative. It's going to be u prime v plus v prime u, right? So this guy turns out to be e to the negative t minus t times e to the negative t, right? Over ds over dt is going to be e to the t, right? Alright, now I'm going to bring this guy to the top. So this guy turns out to be e to the negative 2t minus t times e to the negative 2t, right? I'm going to factor e to the negative 2t out. So it could be 1 minus t, right? Now I'm going to take the second derivative, which is the first derivative of this guy, right? So it could be, so it's going to be d squared y over ds squared is d over dt dy over ds, right? Over ds over dt, right? The formula right here. Alright, so you're going to take the derivative of this guy with respect to t, right? I'm going to use the product rule right here, right? So it turns out to be negative 2 e to the negative 2t times 1 minus t, right? Plus e to the negative 2t times negative 1, right? Derivative of this one equals negative 1 over derivative of this guy with respect to t. So it can be e to the t, right? Now I'm going to simplify the numerator, right? So negative 1 times this one equals negative e to the negative 2t, right? So I'm going to factor e to the negative 2t out. It's going to be negative 2, and then I distribute negative 2 to this guy right here, right? So it could be plus 2t, right? Minus 1 over e to the t, right? So this guy turns out to be e to the negative 2t times 2t minus 3 over e to the t, right? I bring this guy down. So this guy turns out to be 2t minus 3 over e to the 3t. This one is the final answer, right? Now question B, you're going to do exactly the same thing, right? So you have dy over ds equals dy over dt over ds over dt, right? So dy over dt equals this one right here. You're going to use psi u prime. It's going to be u prime times cosine u, right? So u in this situation is 2t, right? So it could be 2 cosine 2t, right? Over ds over dt, which means negative sine t, right? Now, d squared y over ds squared is, we're going to use this formula right here, right? So we're going to take the derivative of this one with respect to t, right? So we're going to use the formula u over v prime equals u prime v minus v prime u over v squared, right? So this guy turns out to be u prime, which means you're going to use the cosine u prime. It's going to be u prime times sine u. Don't forget the negative side right here. So this guy turns out to be negative 4 sine 2t, right? Because you're going to bring 2 to the front and then don't forget negative side, right? Times v, which means times negative sine t right here, right? Minus v prime, derivative of this one equals cosine, right? So minus, and you have negative side here, becomes positive cosine t times u, which means times 2 cosine 2t, right? Over v squared, which means sine squared t, right? And I'm gonna put the equal sign right here. This one is the main fraction, right? ds over dt, right? So s of t is right here, right? So it's gonna be negative sine t, right? Now I'm gonna simplify this one further. So this guy turns out to be negative right here becomes positive, right? So I have 4 sine t sine 2t, right? This guy turns out to be plus 2 cosine t cosine 2t, right? I'm going to combine this guy and this guy, right? So this guy turns out to be negative sine cube of t, right? This one is the final answer. Now let's move on to segment number 2. Finding the slope and concavity, right? The slope, which means the first derivative, right? Concavity, which means the second derivative, right? Now, when the second derivative is positive, the function is concave up, right? When the second derivative less than 0, the function is concave down, right? So we have dy over ds equals dy over dt over ds over dt, right? So you're going to take the derivative of this one with respect to t, right? So this guy turns out to be 1/2 t squared, right? Over the derivative of this one with respect to t is going to be 1 over 2 square root of t, right? Alright, so this guy turns out to be t squared over 2 times 2 square root of t, right? So this guy turns out to be t power 3/2, right? Now, the second derivative, d square of y over ds squared. We're gonna apply the formula right here again, right? So we're gonna take the first derivative of this one right here. It turns out to be 3.5 t raised to the 1/2, right? Over ds over dt, which means 1 over 2 root t, right? So this guy turns out to be 3.5 square root of t times 2 square root of t, right? So 2 and 2 cancel out, it's going to be 3t, right? Now, since we given the point right here, this is actually s and y, right? But s equals this one right here, right? So we have square root of t equals 2, right? This one right here actually equals this one right here. Square both sides of t equals 4, right? Now we need to evaluate the slope, which means dy over ds when t equals 4, right? dy over ds is actually right here, right? So it's going to be 4 raised to the 3.5, right? It's going to be 8. Now, d square of y over ds square when t equals 4 is going to be right here. So it's going to be 3 times 4 equals 12, right? This one greater than 0. The function is concave up, right? Now let's move on to example number 3. We're going to use the fundamental theorem of calculus with parametric equations. Alright, a particle moving along a curve in the xy plane is s position s of t squared t at time t, where the s over dt equals natural log of t plus 1 and dy over dt equals sine of e to the negative t squared for t greater than or equal to 0 at time t equals 1. The particles is s position 2 and 5. Find the slope of the tangent line to the curve at position 2 and 5. Alright, so when we talk about the slope of the tangent line, we talk about the first derivative, right? So we have dy over dx is dy over dt divided by ds over dt, right? Dy over dt is this guy right here, sine of e to the negative t squared over ds over dt is given by this one, natural log of t plus 1, right? Then we need to calculate dy over ds at t equals 1, right? So we substitute 1 for t into this one, right? So we have a sine of e to the negative 1 squared, which is negative 1, right? Over natural log of 2, right? Now we're going to use the calculator to calculate this one. So we're going to add calculator. Now sine of e to the negative 1, which is the inverse, right? So you're going to hit the fraction right here first. And hit trig right here, the outside right here. E to the negative 1, right? So it could be e right here to the negative 1 over natural log of 2, right? So it's going to be control e to the s right here, put 2, hit enter. Alright, so you're going to convert this one to decimal. So you're going to press menu, number, convert to decimal, and press enter. The answer 0.543, right? Now let's move on to question B. Find the x-coordinate of the position of the particle at time t equals 3, which means s of 3 equals how much, right? Now given t equals 1, you have the coordinate points right here. Now we need to use fundamental theorem of calculus. So we have s of 3 equals s of 1, right? Plus the integral from 1 to 3, right? Of this one right here, right? Because we talk about the x coordinates, so we're going to take anti-derivative of the first derivative right here, right? So it could be natural log of 1 plus t dt, right? So this guy turns out to be s of 1 equals 2 right here, right? So it could be 2 plus, now we're going to bring up the calculator. You're going to press menu, calculus, integral from 1 to 3, right? And then you're going to input this function right here, right? So it could be natural log of 1 plus t dt, right? And press enter. Convert this one to decimal. Press menu, number, convert to decimal, press enter. The answer is 2.158. Alright, so total is to be 4.158, right? We're going to explore topic 9.3 at length of curves, parametric equations. Alright, so previously we know that arc length formulas for a curve defined by y of s on the interval s0, s1 is given by the formula the integral from s0 to s1 square root of 1 plus dy over dx squared ds, right? Now, if our curve is represented by parametric equation s equals f of t, which means the function s with respect to t, y equals g of t for t from a to be inclusive, and ds over dt is the first derivative of the function s with respect to t greater than 0. We can rewrite this one as the integral form s0 to s1, the square root of, rewrite one right here. Now I'm going to divide the top bottom by dt square, right? So I get this one right here, right? Now 1 right here can be written as ds over dt square. That's why we're going to write this one in the same denominator, ds over dt square, right? Now for ds right here, I just multiply the top and bottom by dt, right? So I get this one right here, right? Now I'm going to print this one outside the square root sign. So does that mean I have the integral form s0 to s1 square root of over ds over dt, right? Multiply by ds over dt, right? Multiply by dt. This guy right here and this guy right here cancel out, right? That's why you get this one right here, right? Now ds over dt actually derivative of the function s with respect to t. You got this one. And dy over dt is the derivative of the function y with respect to t. That's why you have the formula right here, right? Now the arc-length in parametric form is going to be given by this formula, right? Note that when applying the arc-length formula to a curve, be sure the curve is traced out only once on the interval of the iteration. For instance, x equals cosine t and y equals sine t is traced out once on the interval 0 to 2 pi, but is traced out twice on the interval 0 to 4 pi, right? Now, arc length and distance traveled, we're going to use the same formula, right? Now, let's take a look at the first example. Find the arc length for a parametrically defined curve. Find the arc length of a curve defined by st equals tq plus 2 and y of t equals 2 times t power of 9 over 2 on the interval 1 to 3, right? So you're going to take the first derivative of the function s of t, right? So it turns out to be 3t squared, right? Y prime of t equals 9t power of 7 over 2, right? Then by the formula we got right here, right? So the arc length equals integral from 1 to 3, right? Of square root of s prime of t squared, which is 3t squared altogether square, plus y prime of t squared, which is 9t power of 7 over 2 square dt, right? So this guy turns out to be the integral from 1 to 3 square root of 9t power of 4 plus 81t power of 7, right? dt, right? Now I'm going to factor 9t power of 4 out. So it's going to be integral from 1 to 3 9t power of 4 times 1 plus 9t cubed, right? Alright, so I can print 9t power of 4 out. So it's going to be integral from 1 to 3 3t squared times square root of 1 plus 9t cubed dt, right? Now I'm going to use u substitution to solve this one, right? So I'm going to let u be square root of 1 plus 9t cubed, right? So I have u squared equals 1 plus 9t cubed, right? Take the derivative both sides, so I have 2u du equals 27t squared, right? Now, outside of the square root side, you only see 3t squared dt, right? Then I'm going to divide both sides by 9. So it's going to be 2 over 9 u du, right, equals 3t squared dt, right? Then I'm going to change the lower bound and upper bound. The lower bound is t equals 1, upper bound t equals 3. We have the new lower bound and upper bound, right? U equals, substitute 1 for t into this guy right here, right? So u equals square root of 10. Now substitute 3, this going to be 27, right? 27 times 9. It's going to be 243 plus 1 is going to be 244, right? So it's going to be u equals square root of 244, right? Now L becomes the integral from square root of 10 to square root of 244 of this guy right here, actually u, right? And this guy right here turns out to be 2 over 9 u du, right? 2 over 9 u du. So this guy turns out to be 2 over 9 u cubed over 3 evaluated from square root of 10 to square root of 244, right? So it's going to be 2 over 27 times square root of 244 cube minus square root of 10 cube, right? And this one is the final answer. Now let's move on to the example number 2. Find the distance traveled. A particle moving along a curve in the xy plane is at position s of t, y of t at time t for t greater than or equal to 0, where this s over dt equals inverse tangent of e to the negative t and dy over dt equals 3t over 1 plus 4t cubed. Find the distance traveled by the particle on the time interval t from 1 to 2 inclusive, right? So you have arc length equals the interval from 1 to 2, right? It's going to be right here, right? Square root of s prime of t actually is going to be right here, square, right? So it could be inverse tangent of e to the negative t square plus y prime of t square, which is this guy right here, right? 3t over 1 plus 4t cubed square dt, right? Now, of course, you're going to use the calculator to calculate this one, right? So you're going to press menu, calculus, integral from 1 to 2. After you input the expression right here, you just hit enter. The answer is 0.406, right? Now let's move on to the theorem 9.3b, error of the surface of revolution. Alright, if a smooth curve C is given by the equation s equals f of t and y equals g of t, such that C does not intersect itself on the interval a to b, then the error s of the surface of revolution formed by revolving C about the coordinate axis is given by the formula s equals 2 pi integral from a to b y of t. This one actually the radius s prime of t squared plus y prime of t squared, right? Now when you revolve the curve about the x-axis, then you have the radius, which is y of t, should be perpendicular to the x-axis, alright? Similarly, if you revolve the curve about the y-axis, so you have the radius s of t is perpendicular to the y-axis, right? Keep in mind the radius must be greater than or equal to 0, right? Okay, let's take a look at example number 3. Find the error of surface of revolution. Let's see the arc of the circle s squared plus y squared equals 9. From 3, 0 to 3 1/2, 3 root 3 over 2 as shown in the figure at right. Find the area of the surface from by revolving the curve C about the x-axis, right? So the radius should be this guy, right? And this guy actually y of t, right? Observe that this one is the rectangular form. Now you learn from IB pre-calculus. You need to convert this one to polar form, right? So you know that S of t equals r cosine t, right? The radius right here is square root of 9, which is 3, right? So it's going to be 3 cosine t, right? Now y of t equals r sine t. So it's going to be 3 sine t, right? Now you need to take the derivative of this one with respect to t. So I have s prime of t is negative 3 sine t, right? And this one s prime of t equals 3 cosine t, right? Now you need to square this one, so this guy turns out to be s prime of t square equals 9 sine square of t, right? And y prime of t square is going to be 9 cosine square of t, right? Now you need to find the boundaries of intersection, right? So this one right here is the x-coordinate, right? Since the arc length right here revolving about the x-axis, you need to use x-coordinate, right? So you have 3 cosine of t equals 3. You need to solve for t, right? So cosine of t equals 1, right? So then t equals 0. Now second one, 3 cosine of t equals 3.5, right? Then cosine of t equals 1/2, right? Then t equals pi over 3, right? So the area of the surface is given by the formula s equals 2 pi, the integral from 0 to pi over 3, right? Times the radius in this situation is y of t. Y of t is right here, right? Times square root of s prime t square plus y prime t square, which is right here, right? So you have 9 sine square of t plus 9 cosine square of t. And then don't forget dt, right? So I'm going to simplify this one. It's going to be 2 pi times the integral from 0 to pi over 3, 3 sine t. Now if I factor 9 out, does that mean I have sine square t plus cosine square of t, right? But sine square t plus cosine square t equals 1, so this guy equals 9, right? And take square root both sides. So the answer is 3, right? So this guy turns out to be 3 times 3 equals 9, right? dt. So it's going to be 18 pi. Now anti-derivative of sine is going to be negative cosine, right? So you have negative side right here. Cosine of t evaluated from 0 to pi over 3, right? And then it's going to be negative 18 pi times, substitute pi over 3 for t, right? It's going to be cosine of pi over 3. Substitute 0 for t, it's going to be negative cosine of 0, right? So it's going to be negative 18 pi times cosine of pi over 3 equals 1/2, right? Cosine of 0 equals 1, right? Subtract 1. So it's going to be negative 18 pi times negative 1/2, right? So it could be 9 pi, right? We're going to explore topic 9.4, defining and differentiating vector value functions of AB calculus BC. Alright, first we're going to talk about the vectors in a plane. To represent a vector, we use a directed line segment as shown right here. Alright, the directed line segments PQ has the initial point P and the terminal point Q. Two directed line segments that have the same length and direction are called equivalent. So you look at this one right here. This guy, equivalent, right? Now we call each a vector in a plane and write V equals PQ. Now V right here is the little v. Vectors are typically denoted by the lowercase boldface letters U, V, W. Alright, let's take a look at the first example. Let U be the directed line segments from 0, 0 to 5, 2. And let V be represented by the directed line segment from -1, 3, 2, 4, 5. Show that vector U is equivalent to vector V. Alright, to show that vector U is equivalent to vector V, you need to show that the direction and the magnitudes are the same. Alright, direction is the same thing as the slope. Right, now we need to find the slope of the vector U, right? So this one is S1, Y1. This one is S2, Y2, right? So the slope is Y2 minus Y1 over S2 minus S1, right? So it could be 2 minus 0 over 5 minus 0. It's going to be 2 over 5, right? Now vector V is going to be 5 minus 3 over 4 minus -1, right? So it could be 2 over 5, right? They're both the same thing, right? Now, magnitudes, which means we need to find the distance between 2 points right here, right? So it's going to be square root of y2 minus y1 square, right? Plus s2 minus s1 square, right? And then this guy turns out to be square root of 29, right? Now similarly, this one equals square root of 5 minus 3 square plus 4 minus -1 square. So it's going to be square root of 29. Now they both have the same values, right? So you can conclude that vector U is equivalent to vector V, right? Now, a line segment whose initial point is the origin and whose terminal point is V1, V2 is given by the component form of V given by V equals V1, V2. The components V1 and V2 are called the components of vector V. To convert directed line segments to component form or vice versa, use the following formula. Alright, if point P has P1, P2, point Q has Q1, Q2, then vector V represented by PQ in the component form is written as like this, right? Q1 minus P1, Q2 minus P2, right? And then the length of the vector V equals square root of this one right here, square, right? And then you're going to add them up, right? This is called the magnitudes of the vector V. If vector V is V1, V2, then vector V can be represented by the directed line segment in the standard position from point P is at the origin to point Q as V1, V2. Alright, now let's take a look at the second example. Find the component form and the length of the vector v having initial point right here and terminal point right here. Alright. So you have vector v is v1, v2, right? So it's gonna be -1 subtract 4, right? Comma 2 subtract -6, right? Alright. So it's gonna be -5, comma 8. Now, to find the magnitudes of this one, which means the length, right? So it's gonna be square root of this one right here, square, right? Plus this guy right here, square. Alright, so the answer is square root of 89. Now, we're gonna talk about the vector operations. Alright. First, if you add two vectors, you're gonna move one of them so that the initial sign of one vector is the terminal sign of the other vector. The sum u plus v called the resultant vector is formed by joining the initial point of the first vector to the terminal sign of the second vector. Alright, now I'm gonna keep vector u the same position. I shift vector v down like this and then up like this, right? So I'm gonna get this guy right here, right? Look, to add vector, we move one of them so that initial sign of this vector right here, right? The red vector right here is the terminal sign of the other, the terminal sign right here, right? See? Then u plus v is this guy right here. Subtract the vectors u and v. Now, vector u minus vector v is the same thing as vector u plus negative vector v, right? Negative vector v has the opposite direction of vector v, right? So this is the vector v, right? Now, negative vector v should be this one. So I'm gonna shift this one over here, so it could be like this. Alright, remember, to add vectors, we move one of them so that the initial sign of one vector is the terminal sign of the other vector, so keep that in mind. Then u minus v, right? Now, for vector u equals u1, u2. Vector v is v1, v2, and the scalar k. This one is a constant, so keep that in mind. Alright. The following operations are defined. The scalar multiple of k and vector u is the vector k times u, right? So basically, you're gonna take vector u, you're gonna multiply by k. Now, the vector sum of u and v is the vector u plus v right here. You just add their coordinates. Now, number 3, the negative of vector v is the negative vector v right here. So it's the same thing as -1 times vector v, right? So you're going to multiply -1 by each coordinates right here, right? Now, number 4, the difference of vector u and v is u minus v, and you just subtract their coordinates, right? Now, let's take a look at example number 3. Given vector u -3, 7, vector v is 5, 1. 5 -1/2 times u. So you have -1/2. Vector u is -3, 7. Right? So you just distribute this one, right? So you have positive 3.5, -7 over 2. right? Now, question B, you're gonna take the magnitudes of this one, right? So you're gonna have square root of 3.5 square plus negative 7 over 2 square, right? So you're gonna simplify, it's gonna be square root of 9 over 4 plus 49 over 4, right? So it's gonna be square root of 58 over. Now square root of 4 equals 2, right? Now question C, you're gonna add two vectors, right? So basically you just add this guy and this guy corresponding. This guy and this guy, right? So it's gonna be negative 3 plus 5, comma 7 plus 1, right? So it's gonna be 2, comma 8, right? Question D, you're gonna take the magnitudes of vector u plus vector v, which is you're gonna take the magnitude of this one right here, right? So it can be square root of 2 square plus 8 square. So it's gonna be square root of 68, right? Now 68 can be written as 4 times 17, right? So 4 you're gonna bring it outside, so it's gonna be 2 square root of 17, right? Now, question E, you're gonna take V subtract U, right? So it could be 5 subtract negative 3, comma 1 subtract 7, right? Alright, so it's gonna be 8, comma negative 6. Question F, you're gonna take the magnitudes of this guy, right? So it's gonna be square root of 8 square plus negative 6 square, right? So it could be square root of 64 plus 36, and it's gonna be square root of 100, and it's gonna be 10, right? Now question G, 3 times vector u is right here, right? So if you multiply by 3, you need to multiply each coordinate right here by 3. Multiply each coordinate of vector v by 4, right? 3 times negative 3 is going to be negative 9. 3 times 7 is going to be 21, right? Subtract 4 times 5 is going to be 20. 4 times 1 is going to be 4, right? Now negative 9 subtract 20 is going to be negative 29. 21 subtract 4 is going to be 17, right? Now question H, we're going to take the magnitude of this guy right here, right? So it can be square root of negative 29 square plus 17 square, right? Now square root of 29 square is going to be square root of 841. 17 square is going to be 289, right? So if you're going to add this guy up, it's going to be square root of 1130, right? Let's move on to the next one. We're going to talk about the unit vectors. A unit vector has the same direction as the original vector, but with the length 1 only, right? If v is a non-zero vector, then the vector u is v divided by magnitudes of vector v is a unit vector. Now let's take a look at the example number 4. Find a unit vector for the vector v7, negative 3 and show that it has a length 1, right? So we have the unit vector is vector v, right? Which means 7, negative 3. Divide by its magnitudes, right? Divide by square root of 7 square plus negative 3 square, right? So it's going to be 7, comma, negative 3 over 7 squared equals 49. 49 plus 9 is going to be 58, right? So then I'm going to rewrite this one as 1 over square root of 58 times 7, comma, negative 3, right? Now you just distribute this guy. So it's going to be 7 over square root of 58, comma, negative 3 over square root of 58. You either radicalize this one or you just leave it like this, that's fine, right? Now, shows that the length is 1, right? So when we talk about the length of the vector, it's actually magnitude, right? So, magnitude of vector u is square root of this one right here, square, right? This one right here, square, right? So it could be negative 3 over square root of 58 altogether square, right? So it turns out to be square root of 49 over 58 plus 9 over 58, right? So it's going to be 58 over 58. It's going to be square root of 1 equals 1. So it has been proved, right? Now, the unit vectors 1, 0 and 0, 1 are called the standard unit vectors and are denoted by I, 1, 0 and J, 0, 1. These vectors can be used to represent any vector V equals V1, V2, right? Now, V1 in the x-coordinate, right? So you're going to take V1 times the x-coordinate right here 1, right? Y-coordinate right here should be 0, right? Because when you multiply it, it's only V1. Now similarly, V2 is going to be in the y-coordinate, so x-coordinate must be 0, right? And then I just rewrite this one as I, right? And this guy right here as J, right? So I have this one right here. Now we call V equals V1 I plus V2 J is a linear combination of I and J. The scalars V1 and V2 are called the components of vector V, right? Now example number 5. Let U be the vector with initial point negative 3, 7 and terminal point negative 5, 2, right? And let vector V is 3i minus 2j, right? Write the following as a linear combination of I and j. Vector U is, right? Vector U is the vector with the initial point right here and terminal point right here, right? So you're going to take negative 5, subtract negative 3, right? 2 subtract 7, right? So you have negative 5 subtract negative 3, right? Don't forget to put I right here. Look, it's going to be like this, right? Plus, similarly, 2 subtract 7, right? And this one should be J. Now we're going to simplify. So this guy turns out to be negative 2i minus 5j. Done, right? Now question B. Vector W is for vector U minus 5 vector V, right? So this guy turns out to be 4 times this one right here. Negative 2i minus 5j minus 5 times vector V is right here. 3i minus 2j, right? Now you just distribute, it's going to be negative 8i minus 20j. And then distribute this one, it's going to be negative 15i and plus 10j, right? Now you're gonna combine like terms, this guy right here and this guy right here, right? So it could be negative 23i. And then this guy right here and this guy right here turns out to be negative 10j, right? Now let's move on to the next one. If vector u is a unit vector such that the angle theta is the angle from the x-axis to u, right? So this vector u right here, and the angle theta is right here, right? And the x-axis is right here. Then the terminal point of vector u lies on the unit circle, right? The terminal point is right here. It's gonna be right here, right? And is equal to cosine theta and sine theta, which is I times cosine theta and j times sine theta. If vector v is any other vector such that angle theta is the angle from the x-axis to vector v, then vector v is the magnitude of vector v times cosine theta sine theta, right? And then you just distribute the scalar, right? And you will get this one, right? Example number 6, writing vectors in component form. Write a vector v of length 6, making an angle 60 degrees with the positive axis in component form, right? So the component form is right here, right? So vector v is, you have the length right here, this guy actually absolute value of vector v, right? So it's gonna be 6i cosine of theta, theta is 60 degrees, right? So cosine 60 plus 6j sine 60, right? Now cosine 60, you're gonna draw the unit circle right here, right? The x-axis represents the cosine function. The y-axis represents the sine function. Cosine 60 is the same thing as cosine pi over 3, right? Plus 6j sine of pi over 3. Pi over 3 is going to be somewhere right here, right? So if you project down to the cosine function, it's actually 1/2, right? So you have this one right here must be I, right? 6i times 1/2 plus 6j sine pi over 3 project down to the y-axis is going to be root 3 over 2, right? Times root 3 over 2, right? So you're going to simplify, it's going to be 3i plus 3 root 3j, right? Now let's move on to example number 7, application of vectors. Two third poles are pulling a disabled cruise ship due east. One pulls with a force of 40 tons at an angle of 12 degrees to northeast, and the other at 50 tons at an angle of 18 degrees to southeast. What is the resultant force on the ship and what angle does it travel? Alright, so you need to get the x and y coordinate. Alright, so this one is the east side. This one is the north side. This one is the south side. And this one is the west side, right? Now, the disabled cruise ship is right here. Alright. Now, we have two third poles. One pulls with a force of 40 tons at an angle 12 degrees to northeast. So northeast, which means it's going to be this direction, right?
So 40 turns at an angle 12 degrees, so it could be something like this, right? 40 and the angle right here 12, right? And the other is 50 turns at an angle 18 degrees southeast, which means this direction, so it's going to be negative, right? So be careful. So you have 18 is going to be something like this. 18 degrees. Now, what is the resultant force? So, go back to example number 6 right here. We have the formula is going to be right here, right? So, the resultant force F is, now, the knob is going to be 40 degrees, right? So, it could be 40 times cosine of 12 degree right here, right? I plus sine of 12 degree J, right? If you want to write this one in the I and J component, right? Then the second one right here is going to be plus 50 degree times cosine of, now be careful, this is going to be negative direction, right? So it could be negative 18 degree I, right? Plus sine of negative 18 degrees J, right? Now I'm going to bring up the calculator. I'm going to press calculate. Then you need to be careful. This one is degree, but your calculator mode is radian, right? So you have two different ways to do it. You either convert this one to degree, which is not recommended because most of the problem on the IB exam, we're going to use the radian mode. So if you forgot to switch this one to radian mode, you're going to get the wrong answer for sure. So I strongly recommend you to leave this one as radian mode. Alright, now you still use degree with radian mode, right? So I'm going to press trick cosine 12. Now I'm going to press pi right here. I just put degree right here, and that's in my answer. It's going to be cosine pi over 15. I'm going to convert this one to decimal. So I'm going to press menu, number, convert to decimal, press enter. The answer is 0.978, right? So I have 40 degree times 0.978 I, right? Plus, now similarly, I need to calculate sine 12 degree, right? So I'm going to press trick sine 12 and press pi right here, put degree, hit enter. And then I need to convert this one to decimal, right? So I hit enter, the answer 0.207, right? Now you're going to do exactly the same thing for this guy, right? So I'm going to add 50 times, I'm going to combine like terms, right? So I'm going to take 40 multiplied by this guy right here, and then I'm going to add 50 multiplied by this guy, right? So you just use the calculator, right? The answer should be 86.679 I, right? Minus 7.134 J, right? Now you need to find the magnitude of the force, right? Square root of 86.679 square plus negative 7.134 square. The answer is 86.972, right? And don't forget the unit turns. Now you need to find the angle, right? So the angle is theta equals inverse tangent of y divided by s, right? Y values is right here, right? So it could be negative 7.134 divided by s value is right here, 86.679. Now we're gonna bring up the calculator. So we're gonna press trig inverse tangent right here, and then press the fraction right here. Negative 7.134 over 86.679, right? And press enter. The answer is negative 0.0082 radian, right? Now if you want to convert this one to degree, you just multiply by 180 and divide by pi, right? So you have negative 0.082 multiplied by 180 divided by pi. The answer negative 4.705. So you look at this one right here, you see that it's going to be negative, right? So you need to say that the disabled cruise ship will move 4.705 degrees south of east, which is this direction right here, right? Now let's move on to example number 8. A plane traveling 500 miles per hour in the direction of 120 degrees encounters a wind of 45 miles per hour in the direction of 45 degrees. What is the resultant speed and direction of the plane? Alright, so we need to sketch the x and y coordinate, right? Plane traveling 500 miles per hour in the direction of 120 degrees. So 120 degrees should be right here, right? So this one is 500 miles per hour, and this one is 120 degrees, right? Now a wind has the speed of 45 miles per hour, right? So 45 miles per hour in the direction of 45 degrees. So 45 degrees is going to be right here, and it's going to be 45 miles per hour, right? So similar to example number 7, you have the resultant force. It's going to be F equals 500 times cosine of 120 degree I plus sine of 120 degree J, right? Plus 45 times cosine of 45 degrees I plus sine of 45 degree J. Now we're going to sketch the unit circle. The x-axis represents the cosine function. The y-axis represents the sine function, right? Now cosine of 120, so 120 is going to be right here, right? So when you project down to the x-axis, it's going to be negative 1/2, right? So you have 500 times negative 1/2 I plus sine of 120 is going to be right here, right? It should be root 3 over 2 J, right? Plus 45. Cosine 45 is going to be root 2 over 2 I. And sine 45 is going to be root 2 over 2 J, right? Now we're going to simplify. 500 times negative 1/2 is going to be negative 250 I, right? And then plus 250 root 3 J plus 45 root 2 over 2 I plus 45 root 2 over 2j. Now I'm going to combine like terms. 45 root 2 over 2, I'm going to use the calculator. The answer is 31.819, right? And then I need to add negative 250, right? The answer is negative 218.8. Similarly, you have 250 root 3. Add 31.8198. Press enter. The answer is 464.833. Alright, now you need to find the magnitudes of the force. So this guy is the same thing as square root of negative 218.18 square plus 464.833 square. Alright, so I'm going to print up the calculator. I'm going to press square root of, the answer is 513.49. Now, next, we need to find the direction of the plane, which means we need to find the angle, right? So, angle theta equals inverse tangent of y divided by s, right? Y right here, s right here. Now, I'm going to print up the calculator. Press trig inverse tangent of 464.833 divided by negative 218.18 and then press enter. The answer negative 1.132, right? You need to be careful. The s value right here is negative. So when you calculate the inverse tangent of this one, you need to add pi radians, okay? Which is you learn in IB pre-calculus, right? So this one is the radian, right? Now if you want to convert this one to degrees, you're gonna take negative 1.132 multiplied by 180 divided by pi, right? Plus pi right here, which means 180, right? Now I'm going to print up the calculator. I have this value right here. I'm going to multiply by 180, right? And then divide by pi. Press enter. Then you need to add 180. Press enter. The answer is 115.114 degrees, right? Now you need to conclude that the plane will travel 115.114 from the horizontal, right? Or you can say that the plane will travel 115.114. You subtract 90 degrees, it's going to be 25.114, right? Degrees from west of north, right? This one is west and north right here. So it's going to go this direction right here, 25.114 degrees, right? Now, next one, we're going to talk about the dot products. The dot products of two vectors u, u1, u2, and vector v, v1, v2 is given by u1 times v1 plus u2 times v2, right? Note that the result should be a scalar. Alright, so simply add the product of two similar components, right? So I need to calculate the dot product of vector u and vector v, right? So I have 2 times 5 plus negative 2 times 8, right? So it could be 10 minus 16, it could be negative 6, right? Question B. The scalar number 2, I just bring it to the front, right? So I have 2 times u times v. But u times v equal negative 6 right here. So I have 2 times negative 6. It's going to be negative 12, right? Now question C. U squared, which means u times u, right? So it could be 2 times 2 plus negative 2 times negative 2, right? So it could be 4 plus 4, it's going to be 8, right? Now, question D, v squared is u times v, right? So this guy is the same thing as u times. Now, 5 times 5 is going to be 25. 8 times 8 is going to be 64, so you're going to add them up, right? So it's going to be vector u is 2 comma negative 2, right? Now 25 plus 64, now 25 plus 64 is going to be 89, right? 178 comma negative 178. So the answer for this one should be a vector, so be careful. Now we're going to talk about the orthogonal vectors. Two vectors u and v are called orthogonal, which means perpendicular, if the dot product equals 0, right? Perpendicular, normal, and orthogonal all mean the same thing. However, we usually say that vectors are orthogonal, lines are perpendicular, and lines and curves are normal. Alright, now angle between two vectors. If theta is the angle between two non-zero vector u and v, right? So for example, I have vector u right here and vector v is right here. I need to calculate the angle between two vectors. Then cosine theta equals the dot product between two vectors divided by the product of two magnitudes of two vectors right here. Alright, note that by crossing multiply, right? So if you cross multiply, you have the dot product equals the magnitudes of each vectors multiply each other, multiplied by cosine theta, which is another way of finding the dot product of two vectors. Alright, further emphasizing that the dot product of two vectors is a scalar. Alright, now example number 10. Given vector u right here, vector v right here, and vector w right here. Determine the angle between two vectors and if any of the vectors are orthogonal, right? So vector u and vector v first, we have cosine theta. The dot product between vector u and vector v, right? So 3 times 4 equals 12. Negative 1 times 3 equals negative 3, right? Divide by square root of this one square is going to be square root of 10, right? Times square root of 4 square equals 16, 3 square equals 9, it's going to be 25, right? Now 12 minus 3 is going to be 9 over 5 root 10, right? So I'm going to take inverse cosine both sides, right? So I have angle theta equals inverse cosine of 9 over 5 root 10, right? I'm going to bring up the calculator. Alright, so I'm going to press trick right here, inverse cosine, press the fraction right here, and then you input 9 over 5 root 10. Press enter. convert this one to decimal. It's going to be 0.965, right? And of course, the unit is radian, right? If you want to convert this one to degree, you just multiply by 180 divided by pi, right? Now, question B. Use and W. So, cosine theta is the dot product between U and W right here. So 3 times 2 over 3, which means 2. Negative 1 times negative 8 over 9, which is plus 8 over 9, divided by square root of 3 square plus 1 square is going to be 10, right? Times square root of 2 over 3 square is going to be 4 over 9, right? Negative 8 over 9 square is going to be plus 64 over 81, right? So I'm going to multiply the top and bottom by 9 for this guy right here, right? So I have 36 plus 64 is going to be 100 over 81, right? Now, if I'm going to simplify this one, it turns out to be 26 over 9 root 10 times square root of this one is going to be 10 over 9, right? Number 9 right here I can bring to the bottom, so that's why I get this one. Now 9 and 9 cancel out right here, right? So, and 26 divided by 2 equals 13, 10 divided by 2 equals 5, right? So the answer right here should be 13 over 5 root 10. Now I need to check inverse cosine of this one, so I'm going to press trig inverse cosine, press the fraction 13 over 5 root 10. Press enter. Alright, convert this one to decimal, press menu, number, convert to decimal, press enter. The answer is 0.605 radian. Alright, now the last one, V and W. V right here and W is right here, right? So I have cosine theta equals dot product of V and W, right? So 4 times 2 over 3 is going to be 8 over 3. And 3 times negative 8 over 9 is going to be negative 8 over 3, right? Over the magnitude of this one is going to be square root of 4 square equals 16, 3 square equals 9, so it can be 25 times square root of 2 over 3 is going to be 4 over 9, and this one equals 64 over 81, so the answer we got right here, square root of 100 over 81, right? Now the top is 0, the bottom is 5 times 10 over 9. The answer is 0. Alright, so cosine theta equals 0. We're gonna take inverse cosine both sides, right? So theta equals inverse cosine of 0. This guy actually pi over 2, right? So the angle between two vectors is pi over 2, which is 90 degrees. So then vector V and vector W are orthogonal. Now we're going to talk about the domain of the vector value functions. The domain of a vector value function is the set of all t for which both component functions are defined. Alright, so we look at this one right here. We need to find the domain of each of this one, right? So we know that this one is radical, right? So we have the radical of 4 is going to be 2, right? Radical of 0 is going to be 0, right? But radical of negative 4 is undefined, right? So in order for this one to be defined, we need t plus 1 right here must be greater than or equal to 0, right? It must be these two guys right here, right? It cannot be negative, right? So you have t greater than or equal -1, right? Now this one right here, we have log base a of b is defined when a greater than 0, a not equal to 1, b greater than 0, right? Now natural log of 4 minus t is the same thing as log base e of 4 minus t, right? So e is the Euler number, right? This one already greater than 0 and not equal to 1, right? So we need this one to be greater than 0, right? Look at this one right here, right? So we have 4 minus t greater than 0, then t less than 4, right? So the domain is -1 to 4, right? Let's move on to question B. We need to find the domain of this one. So we have e raised to the negative t is the same thing as 1 over e raised to the t. So t is any real numbers, right? So the domain for this one is all real numbers, right? Now we need to find the domain for this one right here. Now this one is the inverse function of sine function, right? So the input of this one right here is actually the output of this one, right? The output of this one, which means the range, right? So we know that the range of the sine function is from -1 to 1, right? So we need to find the domain of this one, which means -1 to 1, right? Domain of this one is the range of the sine function right here, right? Inverse sine of t has the domain -1 to 1, right? Now we need to combine this guy and this guy, so we need to use the intersection, right? Intersection of the real numbers and this interval right here, actually this interval, right? Now let's move on to example number 12. Sketch the vector value function of t equals t minus 5 I minus j, right? So observe that the one in front of I is the s value, so s equals t minus 5, right? And the one in front of j is the y value, so y equals -1, right? Now remember that y equals -1 is the horizontal line as -1, right? So it could be right here. T equals 0, s equals -5, right? Y is always the same thing, -1, right? So t equals 0, s equals -5, right? So have the first order pair right here, -5 and -1. So s equals -5, y equals -1, it could be right here. So the vector should be this one. Alright, next one, t equals 1, s equals -4, and y still -1, right? So it could be right here. The second vector, right? Now t equals 5 and then s equals 0, right? So it could be s equals 0 right here and y always -1, right? So it could be right here, right? And t equals 10 for example, and then s should be 5, y should be -1, right? So it could be right here. Now let's move on to example number 13. R of t equals 4 cosine t I minus 2 sin t j for t between 0 and 2 pi inclusive. Alright, so we know that s equals 4 cosine t, which is the I component, right? And y equals -2 sin t, which is the j component, right? Now go ahead square both sides, so I have s squared equals 16 cosine square of t, right? Now you need to isolate cosine square of t, so it could be cosine square of t equal s square over 16, right? This one, same thing, you square both sides, so y square equals 4 sine square of t, right? So sine square of t equals y square over 4, right? Now I'm gonna add this guy up vertically, right? So I have s square over 16 plus y square over 4, right? Now sine square plus cosine square equals 1, right? Now this one actually the ellipse. Now observe that this one actually the horizontal ellipse with the equation s minus h square over a square plus y minus k square over b square equals 1, right? The center is h and k, right? Observe that the center in this situation is 0, so the ellipse has the center at the origin, right? Now in order to sketch the ellipse, we know that a square equals 16, right? So I'm going to take square root both sides, so a equals 4. So you just count from the origin to the left 4 units, right? Right here. And to the right 4 units. Now b square equals 4. So then when you take square root both sides, b equals 2. And then you need to count vertically 2 units from the origin. So it could be right here and right here. So the ellipse should be something like this. Now let's move on to example number 14, converting a rectangular equation to a vector value function. So we have the curve y equals s cubed minus 2s squared plus 3s minus 1. Now we just let s equals t, right? So we substitute t for s into this equation. So we have y equals t cubed minus 2t squared plus 3t minus 1, right? Then you have the vector value function r of t is, you just write this way. It could be s first, which means t, comma, and then y should be t cubed minus 2t squared plus 3t minus 1. Or you can write this vector value function in the I and j component, which is t times I, right? Plus t cubed minus 2t squared plus 3t minus 1 times j, right? Rules for vector value functions. When you add two vector value functions, basically you just add the I components and j components right here, right? Now scalar multiplication. When you multiply a number by a vector value functions, you just distribute the scalar like that, right? Now limit of the vector value function when t approaches a. You're gonna take limit of each I and j component, right? If the limit of either or both components of vector value functions fails to exist, then limit of the overall vector value functions fails to exist. Alright? Now continually, a vector value function R is continuous at t equals a if limit of the vector value function when t approaches a equals R of a. Alright? Now let's take a look at example number 15. Given the vector value function R1, R2, and h of t equals 1 over t, we need to calculate the difference between two vector value functions right here, right? So this guy is the same thing as t squared right here, subtract this guy right here, right? So we have t squared subtract 2t squared plus 3, right? And then I component plus the next one, negative 4t minus 1 subtract 2t right here, right? J component right here, right? Now we're going to simplify. T squared minus 2t squared is going to be negative t squared. Negative 1 times 3 is going to be negative 3. I plus, now negative 1 times 4t equal negative 4t minus 2t is going to be negative 6t, right? Negative 1 times negative 1 equals 1, right? So plus 1. J component outside, right? Now question B, we need to take the magnitudes of this guy, right? So basically, you're going to take square root of this guy square plus this guy square. Alright, now I'm going to distribute this one. It's going to be negative, negative right here, I factor out. So I square is going to be positive, right? So I only have t square plus 3 altogether square. And then I need to use the complete square formula, a plus b square equals a square plus 2ab plus b square, right? So this guy turns out to be t power 4 plus 6t square plus 9, right? Now similarly, I'm going to use complete square formula for this one, right? So it turns out to be plus 36t square minus 12t plus 1, right? Don't forget the square root. Now I'm going to simplify this one, so it's going to be t power 4 plus 42t square minus 12t plus 10. This one is the final answer, right? Now question C. Now question C is going to be vector value function of1 of t. I just rewrite, right? So it could be t square I minus 4t minus 1 j, right? Over. Now magnitude of this one is going to be square root of t square altogether square plus negative 4t minus 1 altogether square, right? And then it's going to be t square I minus 4t minus 1 j over square root of t power 4, right? Plus 16t square minus 8t plus 1, right? I just use complete square formula right here, right? Alright, so vector of 1 is right here, of 2 is right here. So when you multiply them, you just multiply I components and then j component, right? So this guy turns out to be t square times 2t square plus 3, right? And negative 4t minus 1 times 2t. So I'm going to distribute this one. It could be 2t power 4 plus 3t square minus 8t square plus 2t. So I'm going to simplify. It's going to be 2t power 4 minus 5t square plus 2t, right? Now h of t's times r1 of t's. H of t is right here, r1 of t is right here, right? So I just distribute this one to each of this one right here, right? So it's going to be 1 over t times t square I minus 4t minus 1 j, right? Now distribute this one is going to be ti minus 4t divided by t is going to be 4, right? 1 divided by t is going to be minus 1 over t j. Question F. H of t is 1 over t, right? Now r2t squared, which is r2t times r2t, right? Now r2t is 2t squared plus 3 and 2t right here, right? So it's going to be 2t squared plus 3 times 2t squared plus 3, right? Plus 2t times 2t, right? So I'm going to simplify this one. It's going to be 1 over t times 4t power 4 plus 2t squared times 3, it could be 6t squared, and this one is 6t squared, it could be 12t squared, right? And then 3 times 3 equals 9 plus 4t squared, right? T power 4 divided by t, it could be t power 3, right? So 4t cubed. Now 12 plus 4 equals 16, right? So plus 16 t squared divided by t, it could be t plus 9 over t. This one is the final answer. Now let's move on to example number 16. Limits of vector value functions. Find the following limits, right? So we need to find the limit of this one when t approaches 3, right? So we need to find the limit of each of these components, right? So we have limit of the first component right here, t when t approaches 3. It's going to be 3, right? Second limit of t squared minus 9 over t minus 3 when t approaches 3, right? So this one is indeterminate form, right? So we need to factor this one, right? So we have limit of t minus 3 times t plus 3 over t minus 3 when t approaches 3, right? So I'm going to simplify this guy and this guy, right? So this guy turns out to be limit of t plus 3 when t approaches 3 equals 6, right? So final answer is 3 right here should be 3i, right? And 6 right here should be plus 6j. This one is the final answer, right? Now, question B. We have limit of e to the negative t when t approaches 0, right? It's the same thing as limit of 1 over e to the t when t approaches 0, right? So this one approaches 1, right? Because when substitute 0 for t, it could be e to the 0 equals 1, right? Now, limit of sine t over 2t when t approaches 0. Now, we know that limit of sine u over u when u approaches 0 equals 1. This one is the formula you learn from unit 1, right? So we look at this one right here. We see that this is 2t, right? And this is 1t, right? So we need to remove 2 right here, right? So can I write this one as limit of 1/2 times sine t over t when t approaches 0, right? It's the same thing as 1/2 times limit sine t over t when t approaches 0, right? So I'm going to apply this formula. It's going to be 1/2 times 1 equals 1/2, right? So the final answer is, this one is the I component, right? So you have I plus 1/2 right here is the J component, right? This one is the final answer. We have limit of e to the negative t when t approaches infinity. It's going to be limit of 1 over e to the t when t approaches infinity, right? So the bottom approaches infinity, this one approaches 0, right? Now limit of 5t plus 1 over t when t approaches infinity, right? So I'm going to factor t out, so it could be t times phi plus 1 over t, right? T and t cancel out, right? So when t approaches infinity, this one approaches phi, right? So finally, you have the answer 0i, which means 0, so you don't need to write it, right? Phi j. So the answer is phi j. Now let's take a look at example number 17. Determine the intervals on which the vector value function is continuous. Alright, so we need to determine if this guy continuous and if this guy continuous, right? So we have 1 over t, right? Now this one is the rational function. This one continuous if t is not equal to 0, right? So you need to say that this one continuous except 0, right? And negative t is always continuous, right? Because this one is the linear function, right? So now you're going to combine this one right here. So finally, r of t is continuous on negative infinity to 0 union 0 to positive infinity, right? Now let's move on to question B. We need to find the domain of this one, right? So we have natural log of t minus 1 is continuous if t minus 1 greater than 0, right? So it could be t greater than 1, right? Now for the tangent function t. Now remember you learned from AB pre-calculus. The tangent function is continuous except n times pi over 2, where n is an odd integer. Now we need to combine this guy and this guy right here. Alright, observe that if n equals 1, you have pi over 2 is always greater than 1, right? If n equals negative 1, it's going to be less than 1, right? So if you draw the number line right here, you will see that 1 is here and n pi over 2 is somewhere right here if n greater than or equal to 1, right? So final answer must be the function r of t is continuous except t equals n pi over 2, where n is a positive integer. Alright, now let's move on to question C. You know that the cosine function always continuous, right? Remember, the cosine function is going to be like this, right? And the inverse of the cosine function is continuous on its domain, and domain of this one should be the range of the cosine function, right? So it could be negative 1 to 1. Now we're going to combine this guy and this guy, which means we're going to take the intersection, right? So r of t is continuous on negative 1 to 1, right? Now we're going to move on to the next one, derivative rules for the vector value functions. First, we're going to talk about the scalar multiplication. So, k is the scalar multiplied by the vector value function. Then, when you take the derivative of this one, you only take the derivative of the vector value function. So, you need to keep the constant k, right? Now, addition and subtraction, you just split them up and you take the derivative of each, right? Now, multiplication by a function, right? So, we have the product rule, right? U times V you learn from unit 2, right? It could be U prime V plus V prime U. So you're gonna do exactly the same thing as you learned before, right? Now if you have two vector value functions, you apply exactly the same thing, right? Now let's move on to example number 18. Vector value functions and differentiation. Now given the function f of t equal this one, the vector value function u of t and vector value function v of t, find each of the following in two different ways. Now question A. We're going to use the product rule formula, right? U times v equals u prime v plus v prime u, right? So this guy turns out to be f prime of t times u of t plus u prime of t times f of t, right? F prime of t equals 2t plus 1 times u of t, which means 1 over t I minus j plus derivative of u of t is going to be negative 1 over t squared, right? Derivative of this one right here. Derivative of this one equals 0, right? So minus 0j times u, which means times f of t, right? So t squared plus t. Now I'm going to distribute this one. So this guy turns out to be 2t plus 1 times 1 over t is going to be 2 plus 1 over t I. 2t plus 1 times j is going to be minus 2t plus 1j. T squared times this one is going to be plus negative 1, right? And t times this one is going to be negative 1 over t and then I, right? Now component j is right here is 0, so it's going to be 0, right? Now I'm going to combine this guy and this guy right here, right? So negative 1 add 2 is going to be 1. 1t add negative 1t is going to be 0, right? So I have 1i minus 2t plus 1j, right? Now I'm going to do the second way, which is I need to distribute this one first, right? So this one right here and distribute is going to be t squared times 1 over t is going to be t, right? T times 1 over t is going to be 1, so I have t plus 1 I, right? Now t squared plus t times j is going to be itself, right? So it could be negative t squared plus t j, right? Now I'm going to take the derivative of this one. So the derivative of t equals 1, derivative of 1 equals 0 I, right? Derivative of t squared is going to be 2t, derivative of t equals 1, right? J. Now I'm going to simplify, it's going to be 1i minus 2t plus 1j, right? The second method is faster than the first method, right? Now, second one, you do exactly the same thing, right? So you have u times v prime is going to be u prime v plus v prime u, right? Now I need to take the derivative of u's first, right? So it's going to be right here. So it can be negative 1 over t squared I minus 0j, right? Times v times t square I minus natural log of tj plus derivative of v is 2ti minus 1 over tj times u, which means 1 over ti minus j, right? Then I'm going to multiply this one out, right? So negative 1 over t squared times t squared is going to be negative 1. So I have negative 1 I. Negative 0 times this one is going to be 0, right? So this is going to be gone, right? Plus 2t times 1 over t is going to be 2, right? So 2i. Negative 1t times negative 1 is going to be plus 1 over tj, right? Now I'm going to combine this guy and this guy, so it could be 1i plus 1 over tj. This one is the final answer for the first case, right? Now the second case, I'm going to distribute first, right? So I have ut times vt, right? So this guy times this guy is going to be ti, right? This guy times this guy is going to be plus natural log of tj, right? Now I take the derivative of this one, so it's going to be 1i, right? Derivative of this one is going to be 1 over tj, right? This one is the final answer, right? So you see that the second way is faster, right?
We'll explore topic 9.5, integrating vector value functions. Alright, you need to explore the integration rules. If the function r of t equals f of t I plus g of t j, where f and g are continuous on the closed interval a and b, and then antiderivative of vector value function r of t dt equals the antiderivative of each of this one right here, right? And then don't forget to add c1 I and c2 j for each of this one, right? When it comes to the definite interval, which means the interval from a to b of r of t dt. It's going to be interval from a to b of f of t dt I plus interval from a to b of g of t dt j. And you don't have the constant right here, right? Because this one is the definite interval, right? You only have the constant when it comes to the indefinite interval, right? Now let's look at the first example. Find the antiderivative of this one, right? So I'm gonna split this one into two indefinite intervals. So it could be antiderivative of t squared I dt plus antiderivative of natural log of t j dt, right? And then this guy becomes antiderivative of t squared dt, right? I plus antiderivative of natural log of t dt j, right? So remember the antiderivative of s to the n ds, it could be s to the n plus 1 over n plus 1 plus c, right? So it could be t cubed over 3, right? Plus c1 all together I, right? Plus antiderivative of this one, we're gonna calculate this one on the side. So we're gonna let u be natural log of t. Then you have du equals 1 over t dt, right? Now dv equals dt. Then v equals t, right? Keep that in mind. Then you have the antiderivative of u dv equals u times v minus antiderivative of v du. Keep this one in mind. Alright, so this guy becomes u times v, which means this guy right here times this guy, right? So it could be t times natural log of t minus antiderivative of v du, v right here, and du right here, right? So it could be t times 1 over t dt j, right? Now I'm going to simplify this one. It could be t natural log of t. This guy and this guy cancel out, right? So you have antiderivative of dt, which is t, right? Don't forget to add a constant c2, altogether j, right? So I'm going to copy this one over here, this guy and this guy. And this one is the final answer. Now let's move on to example number 2. Find the integral from 0 to 1 of this guy. Alright, so I'm gonna separate this guy. It's gonna be the integral from 0 to 1 of e to the negative t dt I, right? Plus the integral from 0 to 1 of 1 over t plus 3 dt j, right? Now remember this formula, the antiderivative of e to the as plus b ds equals 1 over a e to the as plus b plus c, right? Now a in this situation is negative 1 right here, right? So this guy becomes negative e to the negative t, right? I evaluated from 0 to 1 plus, now the second one for this one is going to be antiderivative of 1 over as plus b ds equals 1 over a natural log of absolute value of as plus b plus c, right? So a in this situation is 1, right? So we have 1 over a, which means 1 over 1 equals 1, right? So it could be natural log of absolute value of t plus 3, evaluated from 0 to 1, right? Don't forget I and j. Now I substitute 1 and 0, right? So it could be negative e to the negative 1 minus negative e to the negative 0, right? Don't forget I plus natural log of 1 substitute over here, it could be 4 minus 0 substitute over here, it could be natural log of 3, right? J, right? Now final answer is going to be negative 1 over e, right? This one equals 1, so it could be plus 1 I plus this one right here. I'm going to use log properties, right? So it could be natural log of 4 over 3j, right? This one is the final answer. Now let's move on to the last example. We need to find the antiderivative of this one given the initial condition right here, right? So antiderivative of sine 2t I dt plus antiderivative of 1 over t squared plus 1 j dt, right? Now take antiderivative of this one. Remember we have the formula antiderivative of sine as plus b ds equals negative 1 over a cosine of as plus b plus c, right? So this guy becomes negative 1 over 2, right? Cosine of 2t plus c1 I, right? Now the antiderivative of 1 over 1 plus s squared ds is going to be inverse tangent of s plus c, right? So this guy becomes plus inverse tangent of t plus c2j. Now we're going to use the initial condition right here. Alright, so for t equals 0, substitute over here. So you have negative 1 over 2. Cosine 0 equals 1, so you have only c1 left, right? I plus t equals 0, inverse tangent of 0 is 0, right? Then you only have c2j left, right? Equals the right hand side right here, 1.5 I plus j, right? Now you just equate the coefficient both sides, right? This guy and this guy must be the same, right? And then this guy right here and this guy right here must be the same, right? So you have a system of two equations. The first one is negative 1/2 c1 equals 1/2, and second one c2 right here equals coefficient of this one is 1, right? Now I need to solve for c1. It's gonna be 1 and c2 is 1, right? So the final answer is r of t equals, substitute 1 for c1 and 1 for c2 into this equation right here, and that is your answer, right? So negative 1/2 cosine 2t plus 1 I plus inverse tangent of t plus 1j. Right? We're going to start topic 9.6, solving motion problems using parametric and vector value functions. Alright, we're going to look at the definition, velocity and acceleration. If the function s of t and y of t are twice differentiable functions of t and r is a vector value function given by r of t equals s of t I plus y of t j, then the velocity vector and acceleration vector at time t are v of t is the first derivative of this one. So basically, you need to take the derivative of each component right here, right? Now acceleration, which is the second derivative of this one, right? And then you're gonna take the second derivative of each component, right? Now the speed is the magnitude of this guy, right? So basically, you're gonna take the square root of s prime t square plus y prime t square, right? Now let's take a look at the first example, velocity, acceleration, and speed. A particle moves along a plane curve described by r of t equals 3 sine t over 2 I plus 3 cosine t over 2 j. Question A. Generate a rectangular equation that describes the particle's motion. Alright? So, you know that this guy right here is the s component, right? And this guy right here is the y component, right? So I have s equals 3 sine t over 2, right? Then I'm gonna 5 sine t over 2 equals s over 3, right? Now I'm going to square both sides. It's going to be sine square t over 2 equals s square over 9, right? And y equals 3 cosine of t over 2. Then cosine of t over 2 equals y divided by 3. And then I'm going to square both sides, so it could be cosine square of t over 2 equals y squared over 9, right? Now I'm going to add this guy up vertically, right? So what should I have? I have sine square of t over 2 plus cosine square of t over 2 equals x square over 9 plus y square over 9, right? But this guy right here equals 1, right? So I have x square over 9 plus y square over 9 equals 1. I'm going to multiply both sides by 9. So I have x squared plus y squared equals 9, right? Now we're going to review the circle equation. We have the standard form of the circle equation. It's going to be s minus h squared plus y minus k square equals r square. Alright, so we look at this one right here. We know that h and k right here equals 0, right? Because we don't see anything right here. So the center is h and k, which is right at the origin, right? And the radius right here, you have r square right here equals 9, and the radius is 3, right? Now, question B. Find the velocity vector, acceleration vector, and speed. So we're going to use the formula right here. Velocity vector is the first derivative of this one, right? So have v of t is, take derivative of this one. I'm going to use the formula sine u prime. It's going to be u prime times cosine u, right? So sine t over 2 can be written as sine of 1 over 2 times t, right? So when you take the derivative of this one, it's going to be 3 over 2 cosine of t over 2 I, right? Now the derivative of this one is going to be negative 3 over 2 sine of t over 2, right? J. Now, acceleration is the second derivative of this one or the first derivative of this guy right here, right? So I keep taking the derivative of v of t, right? So it's going to be negative 3 over 4 sine t over 2, right? Minus 3 over 4 cosine of t over 2 j right here, and this one is I, right? Now we need to calculate the speed, right? So the speed is magnitude of v of t, right? So it's going to be square root of this component right here, square. So it will be 3 over 2 cosine t over 2 square plus this component right here, square, right? It's going to be 3 over 2 sine of t over 2 all together square. So 3 over 2 square equals 9 over 4, right? This one is 9 over 4. I'm going to factor 9 over 4 out, right? So I have cosine square of t over 2 plus sine square of t over 2, right? Don't forget the square root sign. Now you know that this guy right here actually 1, right? So it could be square root of 9 over 4. And it turns out to be 3 over 2. Alright? Now let's move on to question C. Shows the particles path on the graph to the right. Be sure to show arrows to indicate direction. So we know that the particle moves along the circles right here, right? X squared plus y squared equals 9. The center is 0, the radius is 3, right? So center right here, radius is 3, so it could be right here, right here, right here, and right here. Now you just connect this point as a circle. Alright, next one, we need to show the arrows to indicate direction. So how do we know if the particles travel? right, clockwise or counterclockwise direction, right? So we need to create a table. Now, if t equals 0, you substitute 0 for t into the first one right here. Alright, you have sine 0 equals 0, right? So x equals 0. Substitute t equals 0 into this equation right here. Y equals 3, right? Because cosine 0 equals 1, right? So you have the first point is going to be right here, right? X equals 0, y equals 3, it's going to be right here. Right here, t equals 0, right? Now we're going to plug in the second value so that t equals pi. The reason why I take pi is because if you substitute pi over here, right, it's going to give you the nice angle, right? So you have x equals 3 sine pi over 2, right? Sine pi over 2 equals 1, so x equals 3. Now y equals 3 cosine pi over 2. Cosine pi over 2 equals 0. So y equals 0, right? So x equals 3, y equals 0 is going to be right here. So at this point, t equals pi, right? And you know that the barcode moves along this way, right? And it's going to be clockwise direction, right? Now question D. Find the velocity and acceleration at t equals pi. So t equals pi, we can use this guy right here, right? So we have v of pi equals 3 over 2 cosine pi over 2 I minus 3 over 2 sine pi over 2 j. Alright, I'm going to simplify. Cosine pi over 2 equals 0, right? So this guy is gone. Now sine pi over 2 equals 1, so this guy equals negative 3 over 2 j, right? Now a of pi. Substitute pi for t into this equation right here. Alright, so you have negative 3 over 4 sine pi over 2 I minus 3 over 4 cosine pi over 2 j, right? Sine pi over 2 equals 1, so the first one is negative 3 over 4 I, right? Cosine pi over 2 equals 0, so this guy turns out to be 0, right? Now we're gonna state the velocity and acceleration vectors right here. Now, at t equals pi, so t equals pi should be right here, right? The I component is gone, right? Which means x is gone. The y component is negative 3 over 2, right? So you see that negative 3 over 2 is going to go this way, and negative 3 over 2, which means negative 1.5, right? So it should be right here. Right? Remember, it's going this way, it should be negative, going this way should be positive, going this way should be positive, and going this way should be negative, right? Now the second one, acceleration at t equals pi. You only have I component, which is you only have the s value, right? The y value equals 0, right? Negative 3 over 4 going this way, right? Because negative right here, right? So it's going to be negative 0.75, right? So it could be something like this. Right, so this one is v of pi, and this one is a of pi, right? Now let's move on to example number 2, motion along a curve. Sketch the path of an object moving along the plane curve given by r t equals t squared minus 3i plus dj, and find the velocity and acceleration vectors and speed at t equals 0 and t equals 2. sketch the velocity and acceleration vectors on your curve below. Alright. Now, first, you need to sketch this one, right? So in order to sketch this one, you need to find the value of t, s, and y, right? Now, the s component is t squared minus 3, right? And the y component is t, right? So you have the t just right here. T, s, and y, right? We're gonna start with 0, right? At t equals 0, substitute over here. The s value is negative 3. The y value is 0, right? Now t equals 1. The s value is negative 2. The y value is 1, right? T equals 2. The s value is 1. The y value is 2. And t equals 3. The s value is 6. And the y value is 3, right? Now, if t equals negative 1, the s value is negative 2. The y value is negative 1. T equals negative 2. The s value is 1. The y value is negative 2. And t equals negative 3. The s value is 6. The y value is negative 3, right? Now we're gonna plot this order pair on the x and y coordinate right here. Now x was 6, y equals negative 3. So negative 3 and 6 it could be right here, right? X equals 1, y equals negative 2. X equals 1, y equals negative 2, it could be right here, right? X equals negative 2, y equals negative 1. So it could be right here. X equals negative 3, y equals 0, it could be right here. X equals negative 2, y equals 1, it could be right here. X equals 1, y equals 2, it could be right here. And x equals 6, y equals 3, it could be right here, right? Now you connect this one is actually the horizontal parabola, right? Now we need to find the velocity and acceleration vectors and speed at t equals 0 and t equals 2, right? So before we're gonna do that, we need to take the first and the second derivative of this one, right? So I have v of t equals 2t I, right? Plus j, right? And then I have v of 0. It's gonna be t equals 0, substitute over here. It's gonna be j only, right? V of 2. Substitute 2 for t over here. It's gonna be 4i plus j, right? Now, the acceleration a of t is the first derivative of this one, right? So it should be 2i, right? Plus derivative of this one is going to be 0j, right? So I don't need to write this one. Alright, so I have a of 0 is going to be 2i, right? And a of 2 is still 2i, right? Now, at t equals 0, the y component is 1, so t equals 0 is right here, right? So, the order pair should be negative 3 and 0 right here, right? So it should be right here. Now, the y component is 1, and it's going up, right? Look, it's positive. So, 1 is going to be right here. So this one is v0, right? Now v of 2, so t equal 2 is going to be right here, right? So the order pair should be 1 and 2, right? S equal 1, y equal 2 is going to be right here, right? Now you have s component is 4, and y component is 1, right? So right at this one, x component is 4, it's going to the right? Because it's positive. So you count 4 to the right. And this is 1 up, right? So it will be right here. So you just get this one. Alright, so this one is v of 2. Now, a of t is equal to I, right? A of 0 equals to I, right? So 0 is right here. T equals 0, right? It's going to be 2I. So you don't have the y component, you only have s component. And 2 is positive, so it's going this way, right? So it could be right here. Alright, so this one is a of 0. Now, a of 2. So t equals 2. Right? So at this point, 1 and 2. So it's going to be right here. Right? So you have s component is 2. So it's positive, right? So it's going this way. So this one is a of 2. Now let's move on to example number 3. Motion along a curve. Number 2. Sketch the path of an object moving along the plane curve, given by r of t equals e to the t I plus natural log of t j. Alright, so this one actually the s and this one actually the y, right? Now we're gonna sketch the t-charts. Remember that the domain of this one is t greater than 0, right? Because you know that the domain of the log function is going to be a greater than 0, a not equal to 1, and b should be greater than 0, right? Now, natural log of t can be written as log base e of t, right? So b in this situation is t right here, right? So t must be greater than 0, right? So I have t right here, s right here, and y, right? So t equals 1, and then s equals e, right? And then y equals 0, right? Because natural log of 1 equals 0. Now t equals 2, s equals e squared, right? Y equals natural log of 2, right? And t equals 3, it could be e to the third, and this one natural log of 3, right? When t approaches 0, then e to the t approaches 1, right? So have the vertical asymptote is right here. Now, at t equals 1, s equals e, y equals 0, right? So, it's going to be somewhere right here. You know that e is the Euler number. It's going to be 2.718, etc. Right? So this guy right here. At t equals 1, s equals e, y equals 0. Right? At t equals 2, s equals e squared. Right? Now you need to convert this one to decimal. Right? So you just press Control and then Enter right here. It's going to be 7.38. Right? It's going to be right here. And y equals natural log of 2, so you just press natural log control, natural log right here of 2, press enter. Convert this one to decimal, press control, enter. It could be 0.693, right? So it could be somewhere right here. Alright, now t for 3, s for e cubed, right? So you're gonna press e cubed, enter, convert this one to decimal. It should be 20 point something, so this is 22, this is 20 point something, it should be somewhere right here. Y equals natural log of 3, so if you press natural log of 3, press enter, convert this one to decimal, it should be 1 point something, right? So it's gonna be right here, right here. Alright, so if you graph it, it could be something like this. Now we can use the calculator to check our work. Alright, so you just go to the home screen, press graph right here. You need to turn the graph into the parametric mode, right? Because this one is the parametric equations, right? So you're gonna press menu number 3, number 4, right? It's gonna be right here. Now you need to enter the function, right? S equal e to the t, right? So it could be e to the t. Y right here should be natural log of t, right? I remember t should be greater than 0, right? So I'm gonna press Control and equal sign right here, right? It should be this guy. And then I just extend this number to number 10. Alright, so I press Enter. It's gonna be something like this. Alright. Now, if you want to know the orientation of this part of the object, you're gonna press Menu, number 5 Trace, number 4 Path Plot, and number 2 Parametric. Alright, and you just press the start animation right here and enjoy. Alright, so you know that the particle moving along this direction. Alright, now question B. Find the velocity and acceleration vectors at t equals 1. The speed is for question D right here, right? Now velocity, we're gonna take derivative of this one right here, right? So we have v of t is e to the t I, right? Plus 1 over t j, right? Now you have v of 1. It's gonna be e to the 1 is gonna be e I, right? Plus 1 over 1 is gonna be 1j, so I just write j, right? Now a of t is, take derivative of v of t, it's going to be e to the t I plus derivative of 1 over t is going to be negative 1 over t squared, right? J, right? Then you have a of 1, it's going to be e I minus j, right? Now question C. Sketch the velocity and acceleration vectors on your curve above and to the right. It's going to be right here. So at t equals 1. Now v of 1 equals e I plus j, right? So at t equals 1, s equals e, and y equals 1, right? Now t equals 1, s equals e is right here, right? Y equals 1, so it could be right here. Alright, so let's go to the right e unit and go up 1 unit, right? So 1 is right here. So the end point should be right here. And this one is v of 1, right? Alright, now similarly, we need to sketch a of 1, right? So at t equals 1, s equals e, and y equals negative 1, right? So it's exactly the same thing. Y equals negative 1 is going down right here, so negative 1 right here. So it should be somewhere right here. So this one is a of 1. Now let's move on to question D. Find the speed at t equals 1. Alright, so you know that the velocity function is right here. Alright, so the space should be magnitudes of this component, right? So it could be square root of e to the t square plus 1 over t square, right? And then you need to evaluate this one at t equals 1, right? It's say t equals 1. So it's going to be square root of e square plus 1, right? You just leave the answer like this. You don't need to convert this one to decimal, right? Now, question E. What happens to the position, velocity, and acceleration as t approaches infinity? Now, you look at the position function r of t right here, right? So have r of t equals e to the t I plus natural log of t j, right? So when t approaches infinity, right? S equals e to the t approaches infinity. Y equals natural log of t approaches infinity, right? Or you can look at the graph right here, right? When t approaches infinity, S approaches infinity. Y right here approaches infinity. You see that it keeps going further to the right and upward, right? So we have this one, right? Now the velocity. So the velocity function is right here, right? So we copy this one down over here. Now when t approaches infinity, the s component is e to the t approaches infinity, right? The y component is 1 over t approaches 0, right? Now the last one, acceleration, is going to be right here, right? So a of t is e to the t I minus 1 over t square j, right? When t approaches infinity, s equals e to the t, which is this guy right here, approaches infinity, and y equals negative 1 over t square right here, approaches 0, right? Now let's move on to statement number 4. A particle starts at rest, which means v of 0 equals 0i plus 0j, right? T equals 0, and then v equals 0. From the points negative 1 and 2, this one is the component I and j of the position, with an acceleration vector of a of t equals I plus 2j. Find the location of the particle at t equals 2. Alright, so given the position function, if you check the first derivative of this one is actually the velocity function, right? If you check the first derivative of the velocity function, it's going to be the acceleration, right? Now, you given the acceleration function, you need to do backwards, right? So you need to take antiderivative of this guy right here to get the velocity function. Velocity function is the antiderivative of the acceleration, right? So it's going to be antiderivative of I plus 2j dt, right? And antiderivative of I here, coefficient is 1, right? So it could be t. Don't forget to add the constant c1, I, right? Antiderivative of 2 is going to be 2t, right? So plus 2t. Don't forget to add the constant c2, j, right? Now we need to solve for C1 and C2. So we're going to use the given information right here. Alright, so V of 0 equals 0i plus 0j, right? So I have V of 0 Substitute 0 for t into this guy right here. So then I have 0 plus c1 I plus 2 times 0 plus c2 j, right? Then this guy actually equals this one right here, right? 0 I plus 0 j, right? Now I just equate the component, right? This guy and this guy must be the same. So I have a system of two equations. 0 plus sig1 equals 0, right? The second one is right here, right? I have 2 times 0 plus c2 equals 0, right? So to solve system of equation, I have c1 equals 0, c2 equals 0, right? Then I have v of t is ti plus 2t j, right? Now I'm gonna find the position function by taking antiderivative of the velocity function, right? So s of t equals antiderivative of v of t dt, right? So it's gonna be antiderivative of ti plus 2tj dt, right? So it's going to be t squared over 2. Don't forget to add c3, right? I plus t squared plus c4j, right? Now we're going to use the order pair right here, right? At t equals 0, the position is -1 and 2, right? So I have s of 0 equals, substitute 0 for t, right? It's going to be c3i, right? Plus c4j. This one equals -1i plus 2j, right? So I just equate the component, right? This guy and this guy must be the same. So I have a system of equation c3 equals -1, right? This guy and this guy must be the same. c4 equals 2, right? So the position function is s of t is right here, right? It's gonna be 1/2 t squared minus 1 I t squared plus 2j, right? Now you need to answer the question, find the location of the particle at t equals 2. So you have s of 2 equals t equal to, substitute 2 for t, so 2 squared equals 4 divided by 2, it could be 2, minus 1 is to be 1, so it should be I, right? Plus 2 squared equals 4, plus 2 equals 6, so 6j, right? So this guy is the same thing as at t equals 2. The particle is s. The point 1, 6. Let's move on to example number 5. A particle with an initial velocity I plus j and the initial position 1, 1 has acceleration vector I of t equals negative cosine t I plus sine t j. Find the location of the particle at t equals pi. Now again, example number 5 similar to example number 4. You need to take antiderivative of the function I of t to get the function v of t, right? So it can be antiderivative of negative cosine t I plus sine t j dt, right? So antiderivative of cosine is going to be sine, right? So it will be negative sine t. Don't forget to add the constant c1, right? This one is the I component, right? Plus antiderivative side should be negative cosine, right? So negative cosine t plus c2j, right? Now we're going to use the fact that initial velocities I and j. What does it mean? It means v of 0 equals I plus j, right? So we have v of 0. Substitute 0 for t into this one, right? So I have sine of 0 equals 0. I only have c1 left, right? c1 I. Now cosine of 0 equals 1. So you have negative 1 right here. So negative 1 plus c2j, right? And this one right here actually I plus j right here, right? Now you just equate the components, right? C1 must be equal to 1, right? So I have a system of two equations, C1 equals 1, and negative 1 plus C2 equals this one right here, 1. I solve a system of two equations, right? So C1 equals 1 and C2 equals 2, right? So my v of t equals negative sine t plus 1 I plus negative cosine t plus 2j, right? Now, to find the position function, I'm going to take antiderivative of the velocity functions, right? So, s of t is antiderivative of negative sine t plus 1 I plus negative cosine t plus 2j dt, right? Now, antiderivative side is going to be negative cosine, and you have negative side, it becomes positive, right? So positive cosine t. Antiderivative of 1 should be t, right? So plus t. And then don't forget to add c3. This one is the I component, right? Antiderivative of cosine t is going to be sine t, right? So it's going to be negative sine t plus 2t, right? Plus c4j, right? At t equals 0, initial position is right here, right? So this guy equals I plus j, right? So I have s of 0, substitute 0 for t into this guy right here. So I have cosine 0 equals 1, right? So I have 1 plus 0, right? Plus c3 I. Now the second one, sine 0 equals 0. 2 times 0 equals 0. I only have c4 left. Plus c4j, right? And this one equals 1i plus 1j, right? Now I just equate the components, right? So this guy equals this guy. So I have a system of two equations. 1 plus c3 equals 1, and c4 equals 1, right? So c3 equals 0 and c4 equals 1, right? Now my answer for the position function is s of t is cosine t plus t plus c3 is going to be 0, right? So I only have this one is the I component, right? Now plus negative sine t plus 2t c4 equals 1 plus 1. This one is the j component, right? Now, we need to find the location of the particle at t equals pi. So, you have s of pi is cosine pi equals -1, right? So you have -1 plus pi. This one is the I component. Now sine pi equals 0, right? So I only have plus 2 pi plus 1 left, right? So this one is the j component, right? Now you can conclude that at time t equals pi, the particle is at -1 plus pi and 2 pi plus 1, right? Now let's move on to example number 6. A baseball is hit 4 feet above the ground and leaves the bat at a speed of 105 feet per second at an angle of 40 degrees to the ground. Write a vector that describes the motion of the ball. Alright, so in order to write the vector, we need to use this theorem, position vector for a projectile. Neglecting a resistance, the path of the projectile lunges from an initial height with the initial speed v0 and an angle of elevation theta is described by the vector function r of t equals v0 cosine theta t I plus h plus v0 sine theta t minus 1 over 2 g t squared j, where g is the acceleration due to gravity. G equals 32 feet per second square or 9.8 meter per second square. To derive this formula, I'm going to prove this formula in the separate video. Alright, we just apply this one into this problem. Now we're going to summarize this one 4 feet above the ground, which is h equals 4, right? The speed 105 feet per second. This one is the initial speed. So v0 equals 105, right? The angle, which is theta, equals 40, right? Now we have r of t equals v0 cosine theta, right? So it will be 105 cosine 40 degree, right? Times t plus h equals 4 plus v0, which means 105 sine theta, which is 40 degree, times t minus 1 over 2 g equals 32, right? Because the unit right here is feet, right? So you're going to use 32. 32 divided by 2, it could be 16, right? So I have 16 over here, t squared. And this one is the j component. And remember, this guy actually the s component, right? And this guy right here actually y component, right? Now question B, determine how high the ball goes, which means the question asks you to find the maximum height. So we look at the y component right here, right? So we need to maximize this function, right? So in order to do that, we're gonna take the first derivative, right? So we have y prime of t equals 105 sine 40 minus 32t, right? Then you're gonna let y prime t equals 0, so that you're gonna find the critical number, right? So it's gonna be negative 32t equals negative 105 sine 40 degree, right? And then t equals 105 sine 40 degree divided by 32. Now you're gonna print up the calculator. Alright, you're gonna press calculate. And then you look at the upper right corner right here. This guy must be degree because you have degree right here, right? So if it's radian, you need to convert it to degree, right? So you're gonna press the fraction right here, put this guy, and then it's gonna be 105 trig sine of 40, right? Over 32. And then you're gonna press enter, right? You need to convert this one to decimal. So you're gonna press control equals right here. It's gonna give you 2.109. Right? Don't forget to include the units, right? So it could be seconds. Question C. There is a 12 feet high fence 325 feet from home plate. Is the ball a home run? Alright, so we have S of t equals 325, right? But S of t is right here, right? 105 cosine 40 degree t, right? So I'm going to let this one equals 105 cosine of 40 degree t. So I'm going to solve for t, right? So t equals 325 divided by 104 cosine of 40, right? Now I'm going to print up the calculator, right? So I'm going to press this guy and put the fraction. It's going to be 325 over 104 times cosine of 40 degree, right? And press enter. Convert this one to decimal. So it's going to be control enter right here. It's going to be 4.07, right? Now we're going to use this value to calculate the height, right? So we have y of 4.079. We're going to use this function right here. Alright, so it's going to be, now I'm bringing up the calculator, right? So I'm going to press 4 plus 105 times sine of 40. And then times 4.079 minus 16 times 4.079 altogether square, right? Press enter. It's gonna be 13.0909. This guy right here is greater than this guy right here, right? 12 feet. So you're gonna say yes, the ball is a home run. Now let's move on to example number 7. Water from a fire hose is discharged at a maximum rate of 80 feet per second from a height 4 feet from the ground. Firefighters can get 25 feet from a burning building. They shoot the water from their hose at an angle of 45 degrees to the ground. Question A. What is the maximum height that the water can reach? Remember, we have the position function. It's going to be R of t is S of t I plus y of t j, right? And we're going to use the theorem right here, right? So we're going to summarize this one. 80 feet per second. This one is the rate, right? So it's gonna be initial velocity, right? And the height right here, this one is the initial height, right? And 45 degrees right here, this one is the angle theta, right? So we have S of t equals V0 cosine theta. So it's going to be 80 times cosine of 45 degree, right? Times Ti for plus 80 sine 45 degree, right? Times T minus 1/2 gt squared, right? Which is 16 t squared, right? This one is the J component. Now, we're gonna use the Y component only. To find the maximum height, we need to take derivative of this one. And then we're gonna find the Greek number, right? So it could be negative 32t plus 80 sine 45 degree, right? And then we're gonna let this one equals 0. We solve for t, right? So t equals 80 sine 45 degree divided by 32, right? And then I'm gonna bring up the calculator. Then it's gonna be 80 times sine of 45 degree over 32, right? Make sure your calculator should be in the degree mode, right? So you're gonna press enter. Then you're gonna convert this one to decimal. So press Control Enter. It's gonna be 1.76777, right? You're gonna find y of 1.76777, right? Negative 16 times 1.7677 square plus 80 times 1.7677 times sine 45 degree plus 4, right? So this one should be 54 feet. Now question B. If the building completely burns down and the firemen are shooting water on the wreckage, how far into the wreckage can the water reach? So the question just asks you S of T. Now if you scan the pictures, the fireman is right here and the fireman is shooting water. Then when water hits the ground, the vertical component equals 0, right? Which is this guy right here equals 0, right? So you have y of t equals 0. You need to solve for t, right? So I'm gonna bring up the calculator. I just store the function y of t, right? So I'm gonna press y of t. And then I'm gonna press Control and this button right here next to number 9. And then I'm gonna put the function negative 16t squared plus 80t times sine of 45 degree plus 4. And then I'm gonna press enter. So I'm gonna go to the home screen graph and then I just put y of s. That's it, because I already stored the function, right? So I'm gonna press enter. It's gonna be right here, right? Now if you zoom this one in, you will see that the values on the left of the y-axis is negative, which does not make sense, right? Because t values cannot be negative number, right? So we're gonna focus on the t value right here, right? So you're gonna press menu, analyze graph, find the zero, right? Move your cursor to the left, move your cursor to the right. The answer is 3.6 right here, right? Now you need to solve for s of 3.6. The function s of t is right here, right? So you have 80 cosine 45 times 3.6, right? So 80 times 3.6 times cosine of 45 degree, right? So I have, now I'm gonna go to the home screen, press calculate. I have 80 times 3.6 times cosine of 45. Press enter. The answer is 203.647. Now we need to answer the question right here. How far into the wreckage can the water reach? Now look at the given information right here. Firefighters can get 25 feet from the burning building, right? So you need to take this one, subtract 25, right? So the answer is 178.647 feet. This one is the final answer, right? Now let's move on to example number 8. A projectile is fired from the ground level at an angle of 10 degrees horizontal. Find the minimum velocity necessary if the projectile is to have a range of 100 feet. R of t equals v0 cosine theta times ti, right? Plus initial height plus v0 sine theta t minus 1/2 gt square, and this one is the j component, right? Now we just plug in values, right? So we have v0 t right here. T is not given, right? Cosine theta, which is cosine 10 degrees, right? And this one is the I component. Plus initial height is 0, right? Look, from the ground level, right? So it's gonna be v0 sine 10 degree, right? T minus g equals 32 divided by 2, it's gonna be 16, so it's gonna be 16 t squared. This one is the j component, right? Now we're gonna sketch the figures. The projectile will start from here, right? And then it's gonna go like this. Then the height right here is 0. The distance from here to here, s of t equals 100 feet, which is given right here, right? And then y right here, when this one hit the ground, y of t equals 0, right? So we have a system of two equations. Now this one right here actually s of t, right? So we have v0 t cosine 10 degree equals 100, right? And this one actually y of t, right? So it could be v0 t sine 10 degree minus 16 t squared equals 0, right? Now to solve this system of equation, I need to solve for v0 from the first equation, right? So first equation v0 equals 100 divided by t cosine 10 degree, right? Second equation, I need to solve for V0. It's going to be 16t squared over t sine 10 degree, right? So I just equate these two guys right here, right? Because they both equal V0, right? Now, this guy right here, t squared divided by t, I only have t on the top. This guy gone, right? Now I just cross multiply, right? So I have 16 t squared cosine 10 degree equals 100 sine 10 degree, right? So t squared equals 100 sine 10 degree divided by 16 cosine 10 degree, right? So this guy turns out to be, divide the top bottom by 4, right? So it's going to be 25 over 4, right? Sine 10 divided by cosine 10 is going to be tangent 10, right? Now I'm going to take square root both sides, so t equals square root of 25 over 4, which is 5 over 2, right? Tangent 10 right here, right? Actually, you have two values. It's going to be positive and negative. But because the time t always positive, right? So I eliminate the negative number, right? So I'm going to bring up the calculator. So it's going to be 5 over 2, which is 2.5 times square root of tangent 10 degrees, right? Then I'm going to press enter. It's going to be 1.04978. Now I'm going to substitute 1.04978 into one of these equations. Then we're going to finish, right? So I'm going to bring up the calculator. Now I'm going to use the first equation, right? It's going to be 100 divided by this value right here. I copy this one down over here. Don't forget parentheses. Times cosine 10 degree. Then you're going to press enter. The answer is 96.7273. Feet per second. We're going to explore topic 9.7, defining polar coordinates and differentiating in polar form. Alright, so half of this topic you already learned in AP Pre-Calculus. Alright, so go ahead, review some concept in AP Pre-Calculus. Alright, first we're going to talk about the test for symmetry. I have the video about this topic. Alright, please check out the link in the description below. It's going to be right here. The second one we're going to talk about graph of polar equations of circle. Alright, I have the link right here. And I also have the link in the description below. Number 3, we're going to talk about the graph of Limacon curves. Number 4, we're going to talk about the graph of Rolle's curves. Number 5, we're going to talk about the graph of Lemniscate curves. Now let's move on to example number 1. Graph each point. You have this one is the polar coordinate, which is radius and angle theta. Alright, so this one is the polar axis, right? And this one is the initial rate. Now if you go counterclockwise direction, the angle is positive. If you go clockwise direction, the angle is negative. The first thing you need to do is to sketch the angle, right? So the angle right here is 7 pi over 6, which is theta is 7 pi over 6, right? Since 7 pi over 6 is positive, right? Then you need to go counterclockwise direction, right? So this one is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and 7 pi over 6 right here, right? The radius is negative 1.5. Now you only use 1.5 right here, right? So 1 is the first circle right here, right? 1.5 is going to be right here, the distance from here to here, right? Now since the radius is negative, so you need to take the opposite right? So opposite to this one is this guy right here. So this one is the point of this guy, right? Now second one, the angle is negative pi over 3, right? So you need to go clockwise direction, right? So negative pi over 3 is right here, right? And the radius is 2, so should be 2 circle, right? So it could be right here. This one is the coordinate of this point. Now let's move on to the next one, coordinate conversions. We need to convert from polar to rectangular coordinate, right? We know that x equals r cosine theta and y equals r sine theta, right? How do we get this formula? We just use trigonometric ratio in the right triangle, right? The angle theta right here, radius is right here. This one is the s, this one is the y, right? Remember, you have sine of angle theta equals opposite over hypotenuse, right? Cosine of angle theta is going to be adjacent over hypotenuse, right? So that's why you get this one right here. And then you convert to this guy, right? Now let's take a look at example number 2 right here. Convert the following polar points to rectangular points, right? So the radius is 2 root 3 and angle theta is pi over 6, right? So you have s equals r cosine theta, which means 2 root 3 cosine pi over 6, right? Now cosine pi over 6 equals root 3 over 2, right? So it could be 2 root 3 times root 3 over 2, right? 2 and 2 cancel out. Root 3 times root 3 equals 3, right? Now y equals r sine theta, right? So it could be 2 root 3 times sine pi over 6, right? Sine pi over 6 equals 1/2, right? So it could be 2 root 3 times 1/2, right? 2 and 2 cancel out, so it could be root 3, right? So you have the order pair s first 3 and then y root 3, right? Now let's move on to the second one. You have the radius is 8 and angle theta is 5 pi over 4, right? So s equals 8 cosine 5 pi over 4, right? So it's going to be 8 times cosine 5 pi over 4 is negative root 2 over 2, right? So the answer is negative 4 root 2. Now y equals 8 sine 5 pi over 4, right? So it could be 8 times sine 5 pi over 4 equals negative root 2 over 2, right? So the answer is negative 4 root 2, right? So you have the order pair negative 4 root 2, comma, negative 4 root 2, right? Now, next one, we need to convert from rectangular to polar coordinates, right? So again, we have the Pythagorean theorem, x squared plus y squared equals r squared, right? This one plus this one equals this one, right? And then you have the tangent theta is going to be opposite over adjacent, right? So it could be y over s right here. So you're given the order pair s and y. You need to convert this one to radius and angle theta, which is the polar form, right? So you need to find the radius and angle theta. To find the radius, you're going to use this formula. To find angle theta, you need to use this formula, right? Now, to find the angle theta, you need to pay attention to following cases, right? Alright, so look at example number 3. You need to convert, this one is S and this one is Y, right? So you need to convert this one to R and angle theta, right? So you have R equals square root of S squared plus Y squared, right? So it could be square root of 9 plus 9. So it could be square root of 18, right? So it could be 3 root 2, right? Now angle theta is inverse tangent of y divided by s, right? So it could be inverse tangent of negative 3 over 3, right? So it could be inverse tangent of negative 1, right? And this guy actually negative pi over 4. Now since s positive, y is negative, so it's going to be case number 4 right here, right? Then you have angle theta is going to be 2 pi minus absolute value of negative pi over 4, right? So it could be 2 pi minus pi over 4. It's going to be 7 pi over 4, right? Alright, so your answer is 3 root 2, comma 7 pi over 4. Alright, question B. Radius is square root of negative 4 square is to be 16, right? This guy square is to be 48, right? Equals square root of 64 and it's going to be 8, right? Now angle theta equals inverse tangent of absolute value of y divided by s is to be 4 root 3 divided by 4, right? So it's going to be inverse tangent of root 3, right? And it's going to be pi over 3, right? Now you have s negative, y positive. It's going to be this guy right here, right? So then the angle theta should be pi subtract this guy right here, pi over 3, right? So it could be 2 pi over 3, right? Then you have the final answer is right here, 8 comma 2 pi over 3, right? Now let's move on to the next one, equation conversions. You need to convert the following rectangular equation to polar equations. Alright, verify by graphing both on the TIS by using two different graph pages, right? So y equals 6. You know that y is r sine theta, right? So it could be r sine theta equals 6, right? So r equals 6 divided by sine theta. And this one is the polar equation, right? Now 6 over sine theta is the same thing as 6 times cosecant theta, right? Now let's move on to question B. You know that s equals r cosine theta, right? So I have 4 times r cosine theta minus 2 y equals r sine theta, right? R sine theta minus 1 equals 0, right? Now I'm going to add 1 both sides and then I'm going to factor r out, right? So I have r times 4 cosine theta minus 2 sine theta, right? Equals 1. So r equals 1 divided by 4 cosine theta minus 2 sine theta, right? Now let's move on to question C. You know that y equals r sine theta, right? Equals 4 times r cosine theta altogether squared, right? So this one turns out to be r sine theta. This one square and then subtract both sides, so it will be 4 r square cosine square theta equals 0, right? Now I'm going to divide both sides by r, so it will be sine theta minus 4r cosine square theta, right? So I need to solve for r, so it will be r equals sine theta over 4 cosine square theta, right? Now, example number 5, we need to convert the polar equation to rectangular equations. Now, r equals negative cosecant theta, so this guy is the same thing as negative 1 over sine theta, right? We need to use the formula s equals r cosine theta and y equals r sine theta, right? So I'm going to multiply both sides by sine theta, so it can be r sine theta equals negative 1, right? So r sine theta is actually y, right? So y equals negative 1. This one is the final answer, right? Now, question B, I'm going to multiply both sides by denominator, right? So it could be r sine theta plus 3r cosine theta equals 2, right? R sine theta actually y plus 3s equals 2, right? Or y equals negative 3s plus 2. This one is the final answer, right? Now question C. I'm going to multiply both sides by denominator, right? So I have r plus 2r cosine theta equals 3, right? Now, remember you have r squared equals s squared plus y squared, right? So this is r, you need to take square root both sides, right? So it could be square root of s squared plus y squared, right? Plus 2 r cosine theta, this guy actually s, right? Equals 3, right? Now, it could be s squared plus y squared equals 3 minus 2s, right? Now, I'm going to square both sides. So it could be s squared plus y squared equals 3 minus 2s all together square, right? I'm going to use complete square formula to expand the right hand side, right? So I have s squared plus y squared equals 9 minus 24s plus 4s squared, right? Then I need to solve for y, right? So y squared equals 4s squared subtract s squared, it could be 3s squared minus 24s plus 9, right? Now I'm going to take square root both sides, so y equals plus and minus square root of 3s squared minus 24s plus 9, right? Now, next one, we need to convert the polar form to the parametric form using this one, right? You have s equals r cosine theta, r equals 4, so it could be 4 cosine theta, and y equals 4 sine theta. That's it, right? Now, question B, s equals r cosine theta, but r equals this one, so it could be 4 sine theta cosine theta, right? And y equals r sine theta, so it could be 4 sine theta square, right? Now question C, you know that s equals r cosine theta, right? But r equals this one, right? So I have 4 over cosine theta times cosine theta, so it could be 4, right? Now y equals 4 over cosine theta times sine theta, right? Right, sine divided by cosine, it could be tangent, so it could be 4 tangent theta, right? Now, let's move on to the polar graphs. Example number 7, we need to graph polar equations. Now, question A, r equals 2. So the radius equals 2, which means you're going to focus on the second circles, right? So it could be this guy right here. Now, question B, angle theta is pi over 3, right? So pi over 3 is right here, right? So it should be the straight line like this. Now, question C, r equals secant theta. Secant theta equals 1 over cosine theta, right? And we multiply both sides by cosine theta, so it will be r cosine theta equals 1. But r cosine theta actually s, so s equals 1, right? Now to graph this one, it should be a vertical line, right? So it could be something like this. Now let's move on to example number 8, graphing polar equation. This guy actually the Rose curve. Please check out the link in this description below to know how to graph a Rose curve. Now let's move on to the next topic, slope and tangent lines. To find the slope of the tangent line to a polar graph, consider a differentiable function defined by r equals f of theta. Alright, and don't forget the parametric equation of the polar form is going to be this guy right here. S equals r cosine theta and y equals r sine theta, right? Now I substitute f of theta for r into this parametric equation. So then I get this guy right here, right? Similarly, I get this guy right here, right? Now, using parametric form of dy over dx given in the previous session, you have dy over ds. This one can be written as dy over d theta divided by ds over d theta, right? I just divide the top and bottom by d theta. That's why I get this one, right? Now, dy d theta, this guy actually derivative of this guy with respect to theta, right? So I'm going to use the product rule, right? So u times v prime is going to be u prime times v plus v prime times u, right? So this guy turns out to be f prime of theta times sine theta, right? Plus cosine theta f of theta, right? Over derivative of this one right here with respect to theta, right? So it could be f prime of theta cosine theta minus sine theta f of theta, right? That's why you get this formula right here, right? Now, to find the horizontal tangents to the polar graphs, we just set the numerator equals 0 and denominator different from 0, right? So this guy equals 0, this guy not equal to 0. To find the vertical tangent to polar graphs, we need to set denominator equals 0 and the numerator not equal to 0, right? If ds over d theta and dy over d theta are simultaneously 0, we can make no conclusion about tangent lines, right? So be careful. Now, example number 9. Consider the cardioid described by the polar equation r equals 1 plus sine theta. Find the slope of the tangent line to the cardioid when theta equals pi over 3. Right? So you know that S equals R cosine theta, right? But R equals this one right here, right? So I have 1 plus sine theta times cosine theta, right? And Y equals R sine theta is going to be 1 plus sine theta times sine theta. This one right here I can distribute, so it could be sine theta plus sine square theta, right? Now dy over ds is the same thing as dy over d theta divided by ds over d theta, right? Dy over d theta, we're gonna use this function right here, right? So it could be cosine theta plus 2 sine theta cosine theta, right? Over ds over d theta, we're going to use this one right here. So we're going to use the product rule, right? So it could be cosine theta times cosine theta, right? Minus sine theta times 1 plus sine theta, right? Now I'm going to simplify the top. I'm going to factor cosine theta out. It's going to be 1 plus 2 sine theta. I'm going to multiply this one, then distribute this one, right? So it's going to be cosine square theta minus sine theta minus sine square theta, right? I need to evaluate this one as theta equals pi over 3, right? So I put theta equals pi over 3 right here, right? So I have cosine pi over 3 equals 1 half, right? So I have 1 half right here times 1 plus sine pi over 3 equals root 3 over 2, and then simplify 2 right here, it's going to be root 3 left, right? Over cosine pi over 3 equals 1 half square equals 1 over 4, right? Sine pi over 3 equals root 3 over 2, right? So minus root 3 over 2. Now this one root 3 over 2 square is going to be 3 over 4, right? Alright, so it's going to be 1 plus root 3 over 2 over the bottom right here. I need to write this guy in the same denominator, right? So 1 4 minus 3 4 is going to be negative 1 half, right? So it's going to be negative 1 plus root 3 divided by 2, right? So the answer is negative 1. So the slope is negative 1, right? Now question B, find the values for the angle theta for which the cardioid tangent line is horizontal or vertical, right? Now first we're going to talk about the horizontal tangent line. Alright, so basically the numerator equals 0, right? This one right here equals 0, right? So it could be cosine theta plus 2 sine theta cosine theta equals 0. Now I'm going to factor cosine theta out. So it could be 1 plus 2 sine theta equals 0, right? So this one is the 0 product, right? So I'm going to let each of this one equals 0. Now this guy turns out to be cosine theta equals 0, theta equals pi over 2, 3 pi over 2. suppose the domain is going to be 0 to 2 pi, right? And this one turns out to be sine theta equals -1/2, right? So theta equals 7 pi over 6 and 11 pi over 6. Now, if you're not strong at trigonometric equation, please check out the link in the description below to review concept in AP pre-calculus. Now let's move on to the vertical tangent line, which is denominator equals 0, right? So denominator is this guy right here. Alright, so I have cosine square theta minus sine theta minus sine square theta equals 0, right? So I have cosine square is going to be 1 minus sine square theta, right? Minus sine theta minus sine square theta equals 0. I need to rewrite this equation as the quadratic equation, right? So negative sine square minus sine square, it could be negative 2 sine square theta, right? Minus sine theta plus 1 equals 0. Multiply both sides by -1. So it could be 2 sine square theta plus sine theta minus 1 equals 0. Right? Now consider sine theta as the variable. So this one turns out to be quadratic equation with respect to sine theta. Right? So I'm going to factor this one out. Right? I'm going to use as method right here. Alright, so you need to find two integers multiply equals a times c, a equal 2, c equal -1, right? So it could be -2. And add up to b equals 1 right here, right? So it could be 2 and -1, right? So you have sine theta plus 2 times sine theta minus 1, right, equals 0. Now you need to be careful with this method. Since the coefficient right here is 2, right, you need to divide the constant right here by 2, constant right here by 2, right? So I have sine theta plus 1 times sine theta minus 1/2 equals 0, right? So this one is the 0 product, right? So sine theta plus 1 equals 0, sine theta equals -1, right? And then theta equals 3 pi over 2, right? The second one, sine theta minus 1/2 equals 0, sine theta equals 1/2, right? Then theta equals pi over 6 and 5 pi over 6, right? Now let's move on to the last example, example number 10. Particle motion of a polar curve. A polar curve R is given by R equals theta plus cosine theta, where theta between 0 to 2 pi. A particle is traveling along the polar curve R so that its position at time t is s of t, y of t, and such that d theta over dt equals 1/2. Find the s over dt at the instant theta equals 5 pi over 6 and interpret the meaning of your answer in the concept of the problem. Alright, so we know that s equals r cosine theta, right? Then r equal this one, right? So I substitute this one for r, so it could be theta plus cosine theta times cosine theta, right? Now you need to take the ds over dt, right? It's going to be, derivative of this one is going to be d theta over dt minus sine theta d theta over dt, right? Times cosine theta, right? I'm going to use the product rule, u times v, right? Now, plus derivative of this one is going to be negative side, right? So I put negative side right here, d theta over dt times theta plus cosine theta, right? Now I need to evaluate this one as theta equals 5 pi over 6, right? So this one is 5 pi over 6. Alright, so I have d theta over dt is going to be given right here, 1/2 minus sine of 5 pi over 6 times 1/2, right? And the whole thing times cosine 5 pi over 6 minus sine 5 pi over 6 times 1/2 times 5 pi over 6, right? Theta right here equal 5 pi over 6 right here, right? Plus cosine of 5 pi over 6. Now I'm going to simplify 1/2 minus sine 5 pi over 6 is going to be 1/2, right? 1/2 times 1/2 is going to be 1/4, right? Cosine 5 pi over 6 is going to be negative root 3 over 2. Minus 1/2 times 1/2 is going to be 1/4, right? Times 5 pi over 6 minus root 3 over 2, right? I'm going to simplify this one. 1/2 subtract 1/4 is going to be 1 over 4 times this one is going to be negative root 3 over 8, right? Now I just distribute this guy, it's going to be negative 5 pi over 24 plus root 3 over 8, right? So it's going to be negative 5 pi over 24. Now, we need to interpret this guy in the context of the problem. So we need to say that ds over dt equals negative 5 pi over 24 represents the horizontal rate of change of the particle as it's traveling along the polar curve at angle theta equals 5 pi over 6. We're going to explore topic 9.8 of AB Calculus BC. Find the area of a polar region, or the area bounded by a single polar curve. Alright, so suppose I have the polar curve R equals f of theta E sketched below. Now I'm going to partition these regions into n sector. Alright, so each sector right here represents as this picture right here. Alright, we have the formula part over whole equals part over whole. So we're going to set up a proportion using this formula. Alright, we know that this one is the angle theta, right, of the sector of the circle, right? This sector is the part of the circle. So we have angle theta over 360, which is 2 pi, right? Equals the area of the sector equals AS right here over the area of the circle is going to be pi r squared, right? Now I need to calculate the area of the sector. It's going to be pi r squared times theta divided by 2 pi, right? So I'm going to simplify this one. I have the area of the sector is going to be 1/2 r squared times theta, right? Now r is given by f of theta right here, right? So I just replace r with f of theta, right? So I have 1/2 f of theta square times theta, right? Now suppose I have infinitely sectors right here, right? Which means n goes from 1 to infinity, right? So I'm going to use limit notation. So I have limit when n approaches infinity of this guy right here when I goes from 1 to infinity, right? And it's going to be right here. Now I'm going to use the integral notation to represent these limits, right? So it could be 1/2 times integral from alpha to beta of f of theta squared d theta, right? That's why we have this theorem right here. Error in polar coordinates. If the function f is continuous and non-negative on the interval alpha beta, where beta minus alpha, which is the angle right here, I call this theta, right? From 0 to 2 pi, then the area of the regions bounded by the graph of r equals f of theta between the radial lines. Theta equals alpha and theta equals beta is given by this one. Alright, now let's take a look at the first example. Finding the area of a polar region. Find the area of one parallel of the rose curve given by r equals 3 cosine 3 theta. Now, first we need to graph this rose curve. Alright, if you want to review how to graph this rose curve in AP Pre-Calculus, please check out the link in the description below. Alright, so I have r equals 3 cosine 3 theta, right? And remember, you have the formula r equals a cosine and theta, right? If n is r, the parallel symmetric about the x-axis, right? Now a equals 3. This is the length of the pedal, right? So you have one circle right here, two circle and three circle right here. The length of the pedal is 3, right? Now we're gonna use the t-charge. This one is angle theta. This one is the radius. We're gonna start from the angle theta equals 0, right? Then substitute 0 for theta into this one. You have 3 cosine of 0, which is 3, right? Because cosine of 0 equals 1, right? If we let the radius equals 0, which is right here. And then we need to find the angle theta right here, right? So how do we do this one? We substitute 0 for r into this equation right here, right? So we have 3 cosine 3 theta equals 0, right? So cosine 3 theta equals 0. Now 0 actually cosine of n pi over 2, right? So then you have 3 theta equals n pi over 2, right? theta equals n pi over 6, right? Now we're going to focus on the counterclockwise direction, right? Which means the angle is positive, so n is a positive integer, right? So n equals 1. We have angle theta equals pi over 6. N equals 2. We have angle theta equals pi over 3, right? But we don't focus on this one much. We're gonna find the first angle right here. Theta equals pi over 6, which is right here, right? So we have the first pedal is gonna be something like this. And we need to reflect this one over the x-axis, so it could be something like this. So to calculate the error of this one, I just take the error of this guy, and then I'm going to multiply by 2, right? Sorry for my mishap. The radius of the pedal should be 3, not 10. Now I'm going to use this formula, right? So I have alpha is going to be 0, beta is going to be pi over 6, right? F of theta is actually the radius, right? It's going to be 3 cosine 3 theta, right? So I'm going to substitute over here. A equals 1/2 the integral from 0 to pi over 6 times 3 cosine 3 theta altogether square d theta. Now we just calculate the error of the upper half of the pedals, right? So then we need to multiply by 2 to get the error of the whole pedal, right? So this guy turns out to be the integral from 0 to pi over 6. Now 3 square equals 9. I put 9 in the front, right? 2 and 2 right here cancel out. Cosine 3 theta square. We're going to use the formula cosine square of s equals 1 plus cosine 2s over 2. So this guy turns out to be, I'm going to bring 2 to the front, right? So it could be 9 over 2. And it's going to be 1 plus cosine 6 theta d theta, right? And then I'm going to take antiderivative of this one. So it could be 9 over 2 times theta plus 1 over 6 sine of 6 theta evaluated from 0 to pi over 6, right? Now I'm going to substitute values, right? So it could be 9 over 2 times pi over 6 plus 1 over 6 sine of pi, right? Subtract 0 plus 1 over 6 sine of 0, right? So this guy turns out to be 9 over 2 times pi over 6. Sine of pi equals 0, right? And this one equals 0, so the answer is 9 pi over 12. Divide the top bottom by 3, so it could be 3 pi over 4, right? Now I'm going to bring up the calculator to check out work, right? So I just press calculate, press menu, calculus, integral right here from 0 to pi over 6, right? And press enter. It's going to be 2.35619. This guy actually 3 pi over 4, right? Press control enter. It's going to be the same thing, right? So this one is correct. Now let's move on to example number 2. Find the error bounded by a single curve. Find the error of the region lying between the inner and outer loops of the limation R equals 1 minus 2 sine theta. Alright, so we have the radius equals 1 minus 2 sine theta. Alright, so we're gonna start from the origin. the error of the shaded regions is the error of the whole thing right here. Subtract the error of the inner loop, right? So we need to find the lower bound and upper bound of the inner loop right here, right? So suppose the point at origin, we have radius equals 1 minus 2 sine theta. And when the point is right at the origin, the radius equals 0, right? So we have 2 sine theta equals 1, right? Sine theta equals 1/2, right? So theta equals pi over 6 and 5 pi over 6, which is this guy and this guy, right? So this one is for inner loop. So we need to find the lower bound and upper bound of the outer loop right here. Now remember that the point travel this way. So on the outer loop, this one is the lower bound, right? And then let's go back to the original point right here. Original point right here actually complete a full circle, right? So it should be pi over 6 right here plus this one is 2 pi, right? So pi over 6 plus 2 pi is going to be 13 pi over 6, right? So this one is the inner loop and outer loop should be 5 pi over 6 and 13 pi over 6, right? So we have the error of the region is the error of the whole thing right here. Subtract the error of the inner loop, right? Now we're gonna use the formula sine square theta equals 1 minus cosine 2 theta over 2, right? Alright, so this guy turns out to be 1/2. The integral from 5 pi over 6 to 13 pi over 6. Expand this one using the complete square formula, right? So it could be 1 minus 4 sine theta plus 4 sine square theta. But sine square theta, I'm going to use this formula, right? So it's going to be 1 and 2 right here. I'm going to combine. So it turns out to be 3 right here. Similarly, I have 1/2 integral from pi over 6 to 5 pi over 6 of 3 minus 4 sine theta minus 2 cosine 2 theta d theta, right? Now I'm going to check the antiderivative of this one, so it could be 1/2 times 3 theta plus 4 cosine theta minus sine 2 theta, right? Evaluated from 5 pi over 6 to 13 pi over 6 minus 1/2 times 3 theta plus 4 cosine theta minus sine 2 theta. Evaluated from pi over 6 to 5 pi over 6, right? Now I'm going to substitute 13 pi over 6 and 5 pi over 6 into this one, so it's going to be 1/2 times 3 times 13 pi over 6, which means 13 pi over 2, right? Cosine of 13 pi over 6 is root 3 over 2, right? So I have 4 root 3 over 2. Now sine of 13 pi over 6, which means sine of 13 pi over 3. So it's going to be root 3 over 2, right? So it could be negative root 3 over 2 minus 3 times 5 pi over 6, which means 5 pi over 2 plus cosine of 5 pi over 6 equals negative root 3 over 2. So I have negative 4 root 3 over 2. Now sine of 2 times 5 pi over 6, which means sine of 5 pi over 3, right? So it's going to be negative root 3 over 2, and negative side right here, it turns out to be positive root 3 over 2. Minus 1 half times 3 times 5 pi over 6, which means 5 pi over 2. Cosine of 5 pi over 6, which means negative root 3 over 2 times 4, it could be negative 4 root 3 over 2. Sine of 5 pi over 3 is going to be negative root 3 over 2, and negative side here becomes positive root 3 over 2. Minus 3 times pi over 6 could be pi over 2. 4 times cosine of pi over 6, it could be root 3 over 2, so it could be plus 4 root 3 over 2. And then sine of pi over 6 times 2, it could be pi over 3, which means root 3 over 2, and it could be negative root 3 over 2. Right? Now, if you simplify this one, the answer must be pi plus 3 root 3. Alright, now we're going to use calculator to check our work. After you input the expression, you press enter. The answer is pi plus 3 root 3, right? Which is correct. Now let's learn how to find the points of intersection of polar graphs. Alright, locate the points of intersection of the polar graphs. R equals 1 minus cosine theta, and R equals 1 by solving this one algebraically, right? So we just equate this guy and this guy, right? So we have 1 minus 2 cosine theta equals 1, right? So 2 cosine theta equals 0, right? So cosine theta equals 0, right? So theta equals pi over 2 and 3 pi over 2, right? Suppose the domain should be 0 to 2 pi, right? So we have the point of intersection is going to be 1 comma pi over 2 and 1 comma 3 pi over 2, right? Now use your graphing calculator to sketch for graphs. What do you notice about the points of intersection? Alright, so I'm going to bring up the calculator. Press graph right here. You need to squeeze this one into the polar coordinate, right? So I'm going to press menu, graph entries, polar right here, right? So the first equation should be 1 minus 2 cosine theta, right? Then you're going to press enter. It's going to be something like this, right? If you want to zoom in, just press menu, number 4 and number 3 right here. Alright. Now for the second equation, R equals 1, you need to press tab right here. You just put 1, press enter. This could be the circle equation. This could be right here. Now observe that you have actually 3 intersections. The first one right here is 1 pi over 2. This one is 1 3 pi over 2, which is we already found in the first equation. Now we miss this one. Why we miss this one? It's just because when you have the radius 1, you also have the radius equals negative 1. Alright, so you have 1 minus 2 cosine theta equals negative 1, right? So you have 2 cosine theta equals 2, right? So you have cosine theta equals 1. And then theta equals 0, right? So you have the coordinate point of intersection is going to be negative 1 comma 0. right? Now let's move on to the last one. We're going to talk about the arc length of a polar curve. You have the theorem right here. Alright, the arc length equals the integral from alpha to beta of the square root of the radius square plus dr over d theta square d theta, right? So let's take a look at example number 3 right here. First, we need to take derivative both sides with respect to d theta, right? So have dr over d theta equals cosine theta, right? So when you square this one, it turns out to be dr over d theta equals cosine square theta, right? Alright, so the outline of this one is the integral from, suppose the domain of the cardioid right here is from 0 to 2 pi. So you have 0 and 2 pi right here. The square root of r squared, which means 1 plus sine theta altogether square plus cosine square theta d theta, right? And then you just print up the calculator, press on right here, hit calculate. You press enter. The answer is 8. We're going to explore topic 9.9 of AB Calculus BC. Find the error of the regions bounded by two polar curves. Remember, the error in polar coordinates is given by 1/2 integral from a to b of f of theta square d theta. Alright, example number 1. Given two polar curves right here. This one is the equation of the circle. Alright, and this one is the equation of the cardioid. So if you graph these two guys on the calculator, you will get a picture on the right hand side right here. Alright, so the error of the shaded regions is the whole thing right here. And remember that this guy and this guy right here symmetric about the polar axis, right? So basically you just calculate the error of one regions and you just multiply by 2 to get the whole thing, right? Now for the upper one right here, this one includes two portions, right? The one is the pink one right here, and the second one is the gray one right here, right? The gray one is bounded by the circle, right? And the line theta equals 2 pi over 3. And the second one is bounded by the cardioid right here. And two lines, it could be theta equals 2 pi over 3 and theta equals pi, right? Now, how do we find 2 pi over 3 and 4 pi over 3 right here? These two guys actually the intersection of the cardioid and the circle, right? So you just equate this guy right here and this guy right here to find the angle theta, right? So we have negative 6 cosine theta equals 2 minus 2 cosine theta, right? So this guy turns out to be negative 6 cosine theta plus 2 cosine theta equals 2, right? So negative 4 cosine theta equals 2. And cosine theta equals negative 1/2, right? And theta equals 2 pi over 3 and 4 pi over 3, right? Now, we need to calculate the error of this shaded region right here. This is A2, right? So let A2 equals 1/2, right? I'm going to use the formula right here. Draw from this guy right here, actually pi over 2 to 2 pi over 3, right? Now, this guy is bounded by the circle, right? So we're going to use the equation of the circle. So negative 6 cosine theta square d theta, right? Press menu calculus integral from pi over 2 to 2 pi over 3. So I'm going to press this button right here to put a fraction, right? So here's the pi over 2. and hit this button right here, put a fraction, and this is 2 pi over 3, so 2 and pi here over 3 of negative 6 cosine. You just press strict right here, cosine, and press pi, put theta right here, and then this one square d theta. Don't forget to multiply by 1/2, right? And press enter. The answer is 3 times 2 pi minus 3 root 3 over 4. Now, to calculate the error A1, we're going to use the same formula, right? So 1/2. Now, A1 is the integral from 2 pi over 3 to pi, right? In this situation, we need to use the equation of the cardioid, right? So it's going to be 2 minus 2 cosine theta square d theta, right? Then we're going to print up the calculator. I just copy this one over here and just change the value, right? So this one is 2 pi over 3. And this one is just pi of 2 minus 2 cosine theta. And press enter. The answer is 4 pi plus 9 root 3 over 4. Alright, basically you just add them up, right? So A1 plus A2 equals 3. Distribute this one, it's going to be 6 pi minus 9 root 3 over 4 plus 4 pi plus 9 root 3 over 4, right? So it's going to be 10 pi over 4, right? And then don't forget to multiply by 2 to get the bottom one right here, right? So now you're going to take 10 pi over 4 times 2. This one is the error of the whole thing, right? So it could be 10 pi divided by 2, it could be 5 pi, right? Now let's take a look at example number 2. Find the error of a region between two curves. Find the error that is inside the limit zone 3 plus 2 sine theta and outside the circle r equals 2. Alright, so here's the equation of the circle r equals 2. And this one is the limit zone. Now what you need to do is to find the intersection between two curves. It's going to be right here and right here, right? So basically you just equate this guy and this guy, right? So I have 3 plus 2 sine theta equals 2, right? So sine theta equals negative 1/2, right? And theta equals negative pi over 6 and 7 pi over 6, right? So this one is negative pi over 6 and this one is 7 pi over 6, right? Now observe that this guy right here and this guy right here, they're both symmetric about the y-axis, right? So basically you just calculate the error of 1 and you multiply by 2, right? Now in order to calculate the error of this shaded region right here, I need to calculate the error of the limit zone right here and subtract the error of the circle right here, right? So the error of the shaded region equals the error of the limit zone subtract the error of the circle, right? The error of the limit zone is 1/2 integral from negative pi over 6 to pi over 2, right? Of this one right here, square, right? 3 plus 2 sine theta square d theta, right? So I'm going to print up the calculator, copy this one over here, and I just change the upper bound, lower bound, right? Negative pi over 6 2 pi over 2. 3 plus 2 sine. Then you just press enter. The answer is 11 times 4 pi plus 3 root 3 over 12. Now the area of the circle is 1/2. The integral from negative pi over 6 to pi over 2, right? Which is from here to here. Now we're going to use this one right here, right? So 2 square d theta, right? So this guy turns out to be 4 theta over 2, evaluated from negative pi over 6 to pi over 2, right? So 4 theta over 2, it could be 2 theta, right? So we have 2 times, substitute pi over 2 for theta, so it could be pi over 2 minus negative pi over 6, right? So I'm going to simplify this one. It's going to be 8 pi over 6 or 4 pi over 3, right? Now, the area of the shaded regions is this one right here, and distribute this one. So I have 44 pi plus 33 root 3 over 12 minus 4 pi over 3 right here, right? And multiply the top border by 4. So it could be 28 pi plus 33 root 3 over 12, right? Now, you need to multiply this area of the shaded regions by 2, right? So multiply by 2. So it's going to be 28 pi plus 33 root 3 over 6, right? Now remember that example number 1 and example number 2 can be calculated without using a calculator, right? Example number 2, very simple, you just use complete square formula and you expand this one, right? And remember we have sine square theta equals 1 minus cosine 2 theta divided by 2. Now for the first example right here, you have cosine square theta equals 1 plus cosine 2 theta divided by 2. Right? Now let's move on to example number 3. This one is the AB style free response questions. The graph of the polar curve r theta equals theta times sine theta times cosine theta is shown in the figure above. For theta from 0 to 5 pi over 2, right? This one is 0 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and this is 4 pi over 2, which is 2 pi. And go back over here, it's going to be 5 pi over 2, right? Let's add the shaded regions in the outer loop of the graph of the r theta and also outside of the inner loop of r theta, as shown in the figure above. Let R be the regions bounded by the graph of r theta in the quadrant 4. So this guy right here. Find the area of R. Alright, so we need to find the lower bound and upper bound of the integral first, right? So what's this and what's this? Now, be careful. The common mistake students always make, they say 3 pi over 2 and 2 pi. However, that's not the case. You need to rewrite this function right here. R theta equals 1/2 theta sine 2 theta, right? Because you have the double angle formula sine 2 theta equals 2 sine theta cosine theta, right? So you need to determine the sine of the radius right here, okay? So you know that the unit circle has The y-axis represents the sine function. The x-axis represents the cosine function, right? So anything above the x-axis, it could be positive value for the sine function, right? Anything below the axis, it could be negative value for the sine function, right? And you know that this guy is 0, this guy is pi over 2, this is pi, and this is 3 pi over 2. And go back over here, it could be 2 pi, right? Now, sine 2 theta is positive for 2 theta from 0 to pi, right? So 0 less than 2 theta less than pi, right? And you solve this one, so theta is going to be greater than 0 less than pi over 2. Now sine 2 theta less than 0 when 2 theta greater than pi less than 2 pi, right? Now divide both sides by 2, so it could be pi over 2 less than theta less than pi, right? Now the first one, sine 2 theta greater than 0, right? If 2 theta greater than, this one is 2 pi and this one is 3 pi, right? So it could be 2 pi to 3 pi. Divide both sides by 2, so it could be pi less than theta less than 3 pi over 2, right? Now the last one, sine 2 theta less than 0 when 2 theta from 3 pi to 4 pi, right? Now divide 3 sides by 2, so it could be 3 pi over 2 less than theta less than 2 pi, right? The sine of the radius right here depending on the sine of sine 2 theta, right? So this guy makes the radius positive. This guy makes the radius negative. This guy makes the radius positive, and this guy makes the radius negative. Now remember, in the polar coordinate, when the radius is positive, the point r theta lies in the direction of angle theta. When the radius is negative, the point r theta is plotted in the direction of theta plus pi, which is directly opposite, right? If you look at this one right here, the interval from pi over 2 to pi, right? Which is this guy right here, quadrant 2. Sine 2 theta less than 0. This guy makes the radius less than 0, right? Because the radius is less than 0, the point r theta is plotted in the direction of theta plus pi, which is in the quadrant number 4 right here, right? So the regions R right here receive the lower bound and upper bound pi over 2 and pi, right? Now go back over here, we have the integral from pi over 2 to pi, right? Of theta sine theta times cosine theta square, right? D theta. Don't forget to multiply by 1/2, right? By the way, I'm going to show you how to graph this polar curve on the polar coordinate using the TIN SPY calculator. Alright, so you're going to print up the calculator. Now, you're going to go to menu number 3 and you pick polar right here. Alright, so you're going to pick theta, so you'll press pi here, put theta times, make sure you put the multiplication right here, and then hit trick right here, put sine, then theta times cosine theta. Alright, then you press enter. It's gonna be right here. See that? This one. Alright, so I'm gonna go to home screen. I'm gonna press calculate. Now press menu, calculus, integral. Don't forget to put 1/2 in the front, right? So press this button, put fraction, and it's gonna be 1/2. The integral form pi over 2 to pi, right? So you're gonna press fraction right here, put pi over 2. Theta times sine theta times cosine theta square d theta, and you press enter. It's going to give you exact value right here. Now if you want to convert this one to decimal, you just press Control enter, and it's going to be 0.552947, right? Now let's move on to the next one. Find the error of the region S right here. The region S right here is the shaded one right here, inside the bigger better and outside the smaller better right here, right? So this guy actually the error of the bigger one subtract the error of the smaller one, right? So you have error of the region S equals 1/2 the bigger one, which means from 2 pi to 5 pi over 2, right? Integral from 2 pi to 5 pi over 2 of theta sine theta cosine theta square d theta minus the smaller one, which means 1/2 the integral from 0 to pi over 2, right? The smaller one is right here, right? It's going to be from 0 to pi over 2 of theta sine theta times cosine theta square d theta, right? Now we're going to print up the calculator. Alright, so I just copy this one over here. I just changed the lower bound and upper bound. That's it, right? 4.844, right? Now let's move on to question C. For theta from pi over 2 to 3 pi over 4, r of theta less than 0 and dr over d theta less than 0. What do these facts say about the curve relative to the origin? Alright, so we're going to go back to this one right here. We know that theta from pi over 2 to pi sine 2 theta less than 0. Then the radius is less than 0, right? The points on the polar curve are in quadrant 4, right? Actually, it's in quadrant 2, but the radius is less than 0, right? So you need to take the opposite one, which is in quadrant 4, right? Now, the question gives you the interval pi over 2 to 3 pi over 4. Pi over 2 to 3 pi over 4 is going to be inside of this interval, right? So it's going to be in the quadrant 4, right? Now, because d r over d theta less than 0, points on the polar curve moving away from the origin. Now let's move on to question D. For the closed interval pi over 2 to 3 pi over 2, find the greatest distance from any point on the polar graph of r theta to the origin. Justify your answer. Alright, so in this situation, we're going to use the candidate test, right? So first, we need to take the derivative of the function r theta equals theta sine theta cosine theta, right? So we're gonna print up the calculator. Now we're gonna grab the derivative of this function, right? So we're gonna press grab right here. We're gonna press menu, go to grab, go to function right here. You're gonna press tab the function f1 as equals derivative, right? So you're gonna press this button right here, right? So you have derivative, it's gonna be right here. Alright, derivative with respect to s, right? And I just press enter, it's gonna be right here, right? Now I need to restrict the domain, right? The domain is from pi over 2 to 3 pi over 2, right? So you're gonna press menu number 4, number 1. Alright, s minimum is pi over 2, right? So I just press pi divided by 2. S maximum is 3 pi over 2. So it could be 3 times pi divided by 2, right? And I just press OK. So it's gonna be right here, right? Now you have two critical values right here, right? This is where r prime theta equals 0, right? So I need to find the critical values right here. So I need to press menu number 6, 0 right here. You need to find 0, right? So go to the left of 0, go to the right of 0, you get 2.46. Now similarly, menu number 6, 0, left, right, it's going to be 3.99, right? So I need to use the candidate test, right? The first value is right here, the endpoints right here, pi over 2, right? The next one is this guy right here, 2.46. The next guy right here, 3.99. And the last one is 3 pi over 2. For pi over 2, you just substitute back over here, right? You know that cosine pi over 2 equals 0, right? So you don't need to use a calculator for this one, right? This guy equals 0. Now, 3 pi over 2, cosine 3 pi over 2 still 0. So this guy 0, right? Now, 2.46. I'm going to go to the home screen. Press calculate, right? Now, I need to store the function, right? Press R parenthesis theta. And then you press Control and this button right here. Alright. It's going to be theta times sine theta times cosine theta. Alright, so you press enter. Whenever you see done, which means you're successful, right? Remember, the distance always positive, right? So you need to put the absolute value, right? So you're gonna press the button right here. The absolute value side is right here, right? Then you just put R of 2.46. Then you press enter. It's gonna be 1.203, right? Now you do exactly the same thing for the second value. It's gonna be 3.99 right here. And press enter. It's gonna be 1.979, right? So I have right here 1.203 and it's gonna be 1.979. Now the radius distance is 1.979 when theta equals 3.99. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun, as she puts her hand in mine.